All right, we are live at Microsoft JDConf 2022. Welcome, folks watching online through the Learn TV. I'm excited to be here with you from Vancouver, Canada. This is my little office at my backyard, and it's a pleasure to be here. Maybe we will see some bears around, but hopefully they will not scare me or neither of any of you. Uh, this is the second edition of Microsoft JDConf, a Java Developer Conference. We will talk about Microsoft technologies, we will talk about partners technologies, and we'll talk about open source technologies available in the Java ecosystem. This is the second edition. The first one was in 2020. 2021 was a crazy year for all of us. We were all with fingers crossed that the situation would normalize very soon. Unfortunately, we were not able to run JDConf in real life. But we're back with this another edition of it in virtually in your screen, and hopefully you will enjoy the content that we have selected with the input and collaboration of the Java community. Um, Today we have a special agenda for the North America or the Americas time zone. I apologize. This edition of JDConf, different from last year, from 2020, was it is that we have 3 blocks for each time zone. So today, at this time, we are doing the Americas time zone, where we're going to have about, let me count here. I lost track of that. 1, 2, 3, 4, 5, 6, 7 sessions where we're going to talk about Spring. We're going to talk about Java SE and security. We'll talk about Quarkus. We'll talk about Java EE and cloud native Java with our special guest, Josh Long. If you know Josh Long from the Spring community, you should be watching his session at 9:30 a.m. That's just an example of the amazing content we have for you today. We also have the Asia Pacific block. That block will start at 7 p.m. Pacific time. But if I'm not mistaken, with time zones are tricky. This, I think, starts in the morning in Asia Pacific. And lastly, we'll have the European block that starts at 2 a.m. Pacific time, but also in the morning of European time zone, Central European time zone. So stick with us, look at the aka.ms/jdconf website, and you will get access to the calendars for each block or all of the blocks in a single download, and you have access to the sessions and agendas and who are the speakers, etc. If you want to participate and collaborate, you can ask for questions for your speakers and moderators in the chat. If you're watching through the Learn TV website, if you're watching through YouTube or other platform, we'll try to stay connected on those chats sections as well. But please check the Learn TV for a better experience. We have more resources on aka.ms/jdconf-resources, so you can learn more about Java and Microsoft technologies and our partners' technologies. And after the event wraps up, all these content will be available to you on demand through aka.ms/jdconf-on-demand. So as part of that participation, make sure that you follow our code of conduct for Learn TV. Too long, didn't read, just be nice and respectful to everybody participating on this. So with that, I would like to get started inviting our first speaker, and that is Ryan Morgan from VMware.
Hey, Bruno, how are you?
I'm good, Ryan. Welcome to the show. Is this your first time at JDConf?
First time at JDConf. Happy to be here.
Awesome.
Great.
Awesome. Yes, that question is tricky because this is the second JDConf. It's not like we had 10, so it's kind of like weird asking that question. But I'm excited to be here with you because today we're going to talk about how VMware has been helping evolving the Spring community, and also how the Java evolution is helping Spring developers, and other things that we have put some nice notes behind the scenes to talk about. So why don't we introduce ourselves first, and then for people watching, Ryan and I will have this chat for the next 25 minutes, and then after that we'll have the first session from Melissa Mckay and Brian Bentz to talk about continuous integration, continuous deployment with GitHub. So Ryan, please introduce yourself.
Great, thank you, Bruno. Yeah, my name is Ryan Morgan. I run engineering here at VMware for developer ecosystems, which is our investments in the Java ecosystem, as well as our .NET investments. I've been a part of the Spring team since 2009, and have been managing the team since 2016 or so. So I've been here through the transition through Spring Boot and Spring Cloud, as well as all of our collaboration with Microsoft on all the work that we're doing with the Spring Cloud starters for Azure.
All right, awesome. Yeah, I've been a Spring developer myself before I got into this vendor ecosystem, like let's build technologies for our users. I was a Spring user developer around between 2005 and 2012, and I did see a lot of changes. Why don't you tell us like this journey that the Spring went through since its inception and where it is today and where it is going?
Certainly. Yeah. So I've really kind of break down the Spring timeline into maybe 3 different kind of eras, right? So Spring's been around for, this will be our 20th year. I would say the first 10 years or so was really kind of transformative as we introduced dependency injection and just kind of a new way for developers to write code. Starting in around 2013 or 14 was really the second generation where Spring Boot became more popular. Folks wanted to run kind of self-contained applications, and that really kind of enabled those applications to be run out on the cloud, right? From there, we kind of had a whole host of other problems that we had around coordination of microservices, which we addressed with Spring Cloud. And really now we're kind of entering what is almost the third act, right? So we're seeing more and more, use cases around kind of edge and functions. There's, things around latency and, kind of density in terms of how you deploy your applications. And we're really kind of addressing that with the upcoming Spring Framework 6 and Spring Boot 3 releases here at the end of the year.
So Spring 6 is coming out, and what I read recently is that the baseline will be Java 17, which is like the latest and greatest LTS release long-term support of Java. So and I also saw this New Relic report about Java adoption out there. What are some of what is interesting for Java developers, Spring developers, to be aligned with these modern Java story, and where to catch for Spring Cloud native developers as well when it comes to cloud deployment?
Right. Yeah. So we're seeing definitely a move. Java 11 is certainly becoming more and more popular. We're also seeing a lot of interest in containerizing your applications. We do a survey every year called the State of Spring Survey. In between 2020 and 2021, we saw an increase from 44% of all applications are being containerized up to 57%. So we're seeing more and more of this kind of trend towards containerization, towards, again, concerns around just the footprint and startup times. And really, that's kind of what we're doing here with Spring Framework 6 and Spring Boot 3, right? So to go to your original kind of question around Java 17 is, really what we're trying to do here is kind of prepare the Spring developer for the next 10 years, right? So it's really kind of a transformational change in terms of kind of this rebaseline on Java 17, as well as a rebase on Jakarta EE. So that's another big change that's coming as part of Spring Framework 6 and Spring Boot 3.
So yeah, that's it's interesting. Like you mentioned Jakarta EE, and like the Java ecosystem, this split between Spring and Jakarta EE. The reality is Spring relies on Jakarta EE APIs a lot. So there is really this collaboration between these two ecosystems, and I expect to see Spring developers collaborating with that evolution as well moving forward. Now with this rebase on Jakarta EE new APIs. I was when we had this chat before, we spoke about the best website in the world. It's start.spring.io, and I wanted to hear from you, like what are some of the numbers that you guys see through this gateway to the internet of Spring developers?
Right. Yeah, it's Josh Long's second favorite place on the internet, I believe. I think his favorite place is production. But yeah, we do get a lot of information. So start.spring.io is a way for developers to bootstrap new applications. Through that we get about 1.6 million projects generated per month. So we do get quite a bit of data on just what the community is doing. And again, kind of going back to the Java 11 story earlier, we are seeing, I think this year was the first time that Java 11 eclipsed Java 8. So, roughly 45% or so of new Spring apps are on Java 11, around 40% are on Java 8. And then we're actually seeing a rapid increase in usage of Java 17. So that's up to 10%. So it's been interesting to kind of see the uptake of usage of Java 17 already.
So it's what I like about these numbers. It's never like 10,000 stuff, 100,000 stuff. You're already talking about millions, right? Millions of downloads, millions of projects created, and that is amazing. And that clearly shows the size of the Java ecosystem and the Spring ecosystem as well. Last time I checked, there are like more than 10 million Java developers in the world. So I'm sure that translates to roughly at least 20, oh, not 20, maybe 30 to 40% are Spring developers. I would guess. I would not throw in the lottery, but that was my wild guess. So you mentioned like Josh's favorite place, production. When developers put applications in production, especially Spring applications, how do they keep track of that? I mean, building an application sounds easy. Moving that to production sounds hard. But maintaining that application in production sounds even scarier. So what are some of the trends that you see and that VMware sees for that part of the journey?
Right. So, I mean, first off, we do see the jar packaging is certainly more popular than more packaging, right? So roughly 95% of all net new Spring apps are using jar packaging. Part of that is to really encapsulate your application and to really be able to track the dependencies that are being used. Spring Boot does provide a fantastic dependency manager in terms of being able to bring in all the dependencies that your application might need. But beyond that, we do see that overall applications are getting more and more complicated, right? The introduction of clouds, hybrid cloud, multi-cloud. There's so many different ways that folks are deploying applications today. So one of the things that we're doing as a part of the Spring Framework 6 and Spring Boot 3 releases is really a refocus on observability, right? So we have Micrometer, which is a fantastic library that we have for being able to collect and publish metrics to a variety of different systems. I believe that today we support around 19 different backends for Micrometer. But we're taking that one step further. And with these upcoming release, we'll be folding in distributed tracing as well. So we have a project called Spring Cloud Sleuth, which has been used to enable that feature. That's moving directly into Micrometer. And then the entire portfolio is getting kind of a direct integration with Micrometer. So we're going to have a much better story around observability coming here in these new releases.
Okay. So with observability, I think there is this interest in better efficiency, right? You keep monitoring your application in production, you keep seeing how your application evolves, and then you try to identify the points where you want to make it better. And I see this trend about going native, going like not necessarily cloud native, as Josh preaches for the past 2 decades, but really like going native in terms of runtime. So what is Spring's roadmap for that?
Yes, this has been a big focus of the team the past almost 2 years. At Spring 1 back in late 2021, we announced Spring Native. At that point, it was 0.11, I think that was released. And really what that was is an experiment that we were running around a new AOT framework for Spring. We had recently now just moved that into the core Spring projects, and it's going to be a focus area for Spring Framework 6 and Spring Boot 3 going forward. So what that gives users is a couple things. So one, it does allow native compilation of your Spring applications down to native executables. So this is a really important, I think, use case or a feature for, again, those low latency type use cases where you might need to start in a few milliseconds versus the traditional JVM startup time of maybe a second or more. So that's one area where I think there's a lot of opportunity for us. But the interesting part about all this is that all the work that's going in to enable this native compilation also is going to benefit the traditional Java developer on the JVM, right? So we're seeing increased startup time or decreased startup times, anywhere from like 4 to 20%. But we're also seeing a reduction in RSS memory as well. So really the work that we're doing around native is going to benefit really all users of Spring, whether you're on the JVM or you're deciding to compile down to a native binary.
So, if I've played with native runtimes before, and one of the most well-known projects right now is GraalVM, and the process of getting an application natively compiled with GraalVM, especially complex applications, is not that simple, right? There are lots of hoops that people have to go through and identify the libraries that are using, if the libraries are even compatible with some of that work. And it's good to see that it is the Spring team going through that exercise to enable the Spring technologies to do that, so end users and end user developers don't have to do that themselves. But when it comes to the benefits for the cloud, what are some of the expectations that developers should have when they go to an actual cloud service? Let's say they go native or they stick to the JVM. What are some of the expectations of developer experience, and what developers actually want to get from a cloud service?
That's a good question. So, in terms of what we're doing with native, right? So, certainly it's not going to be a use case for everything. I think that there's you need to look at the individual problems that you're trying to solve. In particular, the developer experience around using native executables is very different, right? So the compilation phase takes a lot longer. And there's more of a cycle, I guess, in terms of the iterative development that you're doing when you're working with native. So that's kind of maybe one big change in terms of what people could expect. But overall, I think that as you said, like the community and the push towards native, there's a lot of work to be done across the entire Java ecosystem in terms of being ready for this kind of large change towards going native.
Yeah, clearly there are trade-offs, right, that developers have to choose from. I like to say that YAML is one of the best trade-offs in developers' lives, because they are trading off all the developer productivity versus finding white spaces on YAML files. So all these advancements in technology are being traded with YAML. So I think when it comes to native and the JVM hotspot, it's a similar discussion, right? I'm gaining on this, but I might be losing on this. So that it's important that developers understand what is the true benefit for their particular application, right? Of course, we all want things to go faster, but it's also the question whether you want to go faster. You want to go faster at the beginning, or you want to go faster on the long run. So for cloud applications, we see this trend about deployment on Kubernetes or services where you have this horizontal scaling to support demand. And I think that for that, native is quite interesting. Do you see this customer exercise, this developer exercise where should applications scale out, should applications scale up? Where are they gaining in startup time, tail latency? Even like how does VMware deal with those sort of conversations with customers?
Right. So this is another kind of maybe benefit, right? So the native story that we have, the scale out horizontally is certainly something there where you can really rapidly create new instances to handle new traffic. And maybe going back to your previous comment just around all these trade-offs that people have to go through, that's one of the areas where, we do try to reduce the toil for developers. We are big believers in build packs. In fact, I believe in Spring Boot 2.3, we introduced the build pack support directly into the Maven and Gradle kind of lifecycle. So you can actually be creating your containers, directly from your command line. And then also taking advantage of all the other kinds of deployment options that we might have. So there's a build pack for doing native images. There's ones that are experimental that will layer application code in different layers in your container from maybe the dependencies. And that allows you to do things like upgrade your version of Java or upgrade dependencies without really needing to repush your application code. So there's a lot of things here that the Spring team kind of thinks through and tries to kind of reduce that toil for developers. And that's really kind of what we try to do here at VMware, is just make it as easy as possible to get your code from the laptop to production.
Right. Yeah. I did play with a Spring Tool Suite. I think is that called the extension for Eclipse. Yeah.
Yep. Spring Tools. Yeah.
And I think even like on IDEs are more like Maven focused, perhaps. The Azure Studio Code relies a lot on Maven and just the raw build elements. And I think there are even like things for Spring there that allows developers to have this more like faster development cycle where they can just make changes and experiment with things. So it's nice to see that. So the last thing I think I'd like to touch with you is Azure Spring Cloud. I mean, it was a service announced, I think 2 years ago, or more, right? I think 3 years ago. And I wanted to hear like what are the impressions so far? It's been GA for a while. Customers are using, developers are in love with the idea of having a managed service for Java applications and Spring applications. What are some of the benefits and what is the roadmap looking like?
Yeah, so this has been a collaboration between Microsoft and VMware that's been going on for a while. Like all great collaborations, it started out in open source. So back at I believe Spring 1, maybe even 2017 or 18, we started talking about how do we get developers on Azure more productive? How can we create kind of the starters and connectors so that Spring developers can consume Azure services in a real seamless way? And really, that kind of open source collaboration almost kind of dovetailed more into more of a commercial partnership between Microsoft and VMware. So 2019, we announced the service at Spring 1. This past December, it went into public preview. So anybody can go onto Azure, just search for Azure Spring Cloud. It's in public preview. We will have more details to share here soon. It's not quite in GA yet. I believe the GA date is set for early in June. But really, we're offering the ability for really any Spring developer to essentially push their code, consume things like service discovery, things like distributed configuration, really all the things you would expect from Spring Cloud, but really have that be in just a managed way. So really all you need to worry about is your own application code itself. There's a variety of dashboards as well, so you can visualize your applications. So it's really a great option for anybody who wants to have kind of that self-service kind of hosted experience around Spring.
So I like to, we didn't talk about this, but I'd like to throw in and see how you react to this. So Spring Cloud, very distributed microservice development approach, right? But lots of developers still kind of prefer monolithic applications and just, Spring Framework or Spring Boot, but everything on a single application, the UI, the front end, the REST APIs, database connection. What is the trend looking like here? Are we really going full microservice? Are monolithics will live forever? What do you see?
I think you need to choose the right tool for the job, right? I mean, obviously, microservices aren't really for everyone. I think there is the must be this tall to ride kind of joke that people have around this. So in many cases, we have customers that have legacy Spring applications that are monoliths that they just lift and shift, and they have that be running in a container somewhere. They might take bits and pieces of that, so that maybe they front that with Spring Cloud Gateway. They take portions of it off into a microservice that might need to scale or have different scaling characteristics. But overall, I think that we we see that more for the brownfield or like the older applications that are maybe not being targeted for to be modernized. For a lot of net new applications, I do see more of a trend towards microservices, and again, that's kind of why we're seeing this kind of this interest in things like Spring Boot and Spring Cloud. It's really around the coordination of all those pieces.
Okay, so no, we cannot announce yet the death of monolithic applications. Too soon, right? Okay, cool, excellent. The other thing we talked about was CI/CD, and you mentioned this before briefly, like how going native, for example, can impact that process. So where do you see like where should customers pay attention to with CI/CD platforms, their development cycle, and what are some of the interesting services and technologies out there that can help them on that journey to make sure that their flow continues, their software flow continues without much of impact, even though they're modernizing with technologies that technically can impact on that.
Right. Yeah, I mean, we don't really have a definitive view on what CI/CD is best. Within the Spring team, we use a tool called Concourse. It's something that's been in use by the Cloud Foundry community as well. It's really a great way to be able to visualize your pipelines. We used to have screens here back when we were in the office. There'd be screens here everywhere. It's kind of showing you the status of various pipelines. And then in terms of the DevOps kind of workflows, we are starting to do more around kind of automatic publishing of artifacts. Things like pushing to Artifactory using their CLI plugin. That's happening today in Spring Cloud Dataflow. And we're looking to do more and more of that across the portfolio as well.
Okay, awesome. We are talking about the calendar of conferences. Conferences are starting to get back. We couldn't do JDConf on site, but conferences are coming back. I mean, this week is JFocus happening in Sweden, and lots of Java community folks are there speaking and presenting. What are some of the places that Spring developers should pay attention to go and watch and learn more about the things that you described here, like Spring Framework 6 and the future roadmap of Spring technologies?
Certainly, yeah. There's no shortage of conferences you can go to. Spring I/O Barcelona is coming up here at the end of May. That's always been a great conference, especially for those folks that are in Europe that can get there. We also have Spring One Tour, which is a kind of a mini series of Spring One that happens throughout North America. You go to Spring One Tour, or you can just Google Spring One Tour to kind of find the dates. But we're looking at Toronto, New York, Seattle, Atlanta, and then Amsterdam towards the end of the year. And then we are back in person this year for Spring One. So Spring One will be here in San Francisco at Moscone Center. And I believe that's December 6th to the 8th. So keep your calendars marked for that one.
Yeah, I'm going to book my travel right away. Because I really want to go back to San Francisco. It's been a while. Awesome. Ryan, any last message you want to give to folks watching or Spring developers? Like what excites you and VMware, and where do you want to see Spring developers at in the near future?
Yeah, I mean, there's never been a better time, I think, to be a Java developer. It's been really interesting here over the past couple of years to see Amazon with Corretto. You have Microsoft and all the work that you've been doing around Adoptium and the Eclipse Foundation. So really, there's no shortage of options for developers out there. We're also seeing just an increase in overall Java developers across the world. So it's never been easier to write Java code. It's never been easier to deploy it. Again, Azure Spring Cloud, things like that enable you to really get from code to production very, very quickly. So it's a very bright future, I think, for everybody on the JVM. And again, I'm really happy to be here talking with you about it.
Awesome. Ryan, thank you so much for being here with us. And stick with us actually for a little bit. We're going to introduce the next speaker, but I want to wrap up this call. So thank you for being here.
All right. Thank you, Bruno.
All right. So we're gonna have our next speakers for this 5-minute fire chat between speakers. That's something that we did at the first JDConf, and we are trying to do that again. So next speakers are Brian Bentz and Melissa Mckay. And so let's welcome them. Hello, Brian, Melissa. How are you?
Hi.
Good. Hey.
Hey, Brian.
All right, let's go first with Melissa, because let's put some order in the house, okay? So, Melissa, welcome. How are you?
Hi, I'm doing great. I love that you just mentioned, other conferences going on right now. I'm definitely doing that. Just finished up the second day of JFocus here in Sweden.
Awesome. Yeah, amazing to see that happening. It's really exciting to see conferences happening and people getting together again and snapping pictures of their food and making everybody else feel hungry over the internet. That's amazing. Thank you. Brian, how are you, my friend? It's been a while.
I know it's been too long. How you doing?
Yeah, I'm doing great, man. Whereabouts? I know Melissa in Sweden. Where are you?
I am in sunny Las Vegas. This is my home for many years, and but I did just actually finish a conference in Atlanta, DevNexus, and next week I'll be at DevOps UK. So back on the road for me as well.
Awesome. So good to see that. Like everybody putting their miles up to use again. That's good. So I like what Melissa and Ryan. I hope you're watching a little bit of what Ryan was talking about. And Ryan mentioned CI/CD in the end. And I know your talk is about putting stuff in the cloud through Artifactory and JFrog's Artifactory and CI/CDs. You mentioned also GitHub Actions. I mean, let's put some sense in that. What should developers expect in 9.05?
Yeah, I can take that, Melissa, if you're right. Yeah, it's so the demo I'm going to show today is delivering code from your GitHub repo to a Azure App Service using GitHub Actions. So GitHub Actions is actually a great way to do CI/CD. It's a great segue there. And Melissa is here because we're working together on a partnership with Artifactory. A JFrog Artifactory is a great way to store your artifacts as well. So Melissa, do you have anything to add to that?
Yeah, definitely. So this is a cool talk. I love the way we've organized it is I'll do the high level concepts. So we'll describe a little bit about what we're doing and why it's important. And yeah, Brian will jump in with a demo and show actual implementation. I feel like a lot of talks, sometimes we forget to tell the why we're doing what we're doing. So we plan on doing that today.
Awesome. Ryan, it's your turn, man. Like, what would like to ask them? Like, hey, make sure you show this thing.
I'm really excited to see this demo. I've been talking to some of our team. We have a very broad portfolio of projects. I'd be curious if Melissa knows like how much Spring represents within Artifactory. I know that we have quite a few artifacts up there. But we have transitioned one of our projects to use GitHub Actions along with the JFrog CLI to do our publishing and promotion of artifacts all the way up into Maven Central. So it's a very it's very early. It's only one project today, but I'm kind of interested just to kind of hear the story here and see what we can learn.
All right, awesome. Ryan, I'll let you go now. You're free. Have a wonderful day in the Bay Area, California. And Melissa and Brian, I'll let you go on stage and start. All right, see you soon.
Sure, great. So I've got the slides here up, and I think that's a good way to do it. Melissa, I'll just forward the slides, just tell me when. I'll start by just saying welcome. My name is Brian Bentz. I'm a cloud advocate at Microsoft, and I'm here with Melissa. Melissa, you want to tell us a little bit about yourself as well?
Hi, yeah, definitely. I am Melissa Mckay. I currently work for JFrog as a developer advocate. I've been with them for a little over 2 years now. And prior to that, I was a developer, so very much involved in all the processes and all of the work that developers do, getting our code managed and delivered out there into production. So excited to work with Brian today to show you this demo.
Cool.
Yeah. We're going to be, talking about the concepts, of course, DevOps concepts, including the landscape, Artifact management, especially, that's the part that I'm going to be talking about the most, dealing with Artifactory and how you might want to manage your external dependencies, things like that. And then the second half of this will be Brian's demo. Next slide, please. Uh-oh, can you hear me? I think I lost connection. Hi, I think I lost connection there. Not sure if it was Brian or with me. Okay, if it's Brian, I'm going to go ahead and share my screen. I have my slides here, so we'll get going until he can get back on. Let me go ahead and share. Get to the right spot. Okay, we're back. All right, you should be able to see my screen now. Can you see my slides? I don't think that my slides are being added to the background. Awesome. Yes, success. This is what we do every day, is we solve problems. So here we go. Once again, we're going to get started here. This is just our agenda that we're going to be working with. Okay, so the very first thing I want to talk about is just what do we really care about when it comes to our processes, and mainly our pipelines, our development pipelines and our deployment pipelines. And this is a picture of my car. I actually showed this picture the last time I presented over maybe 2 years ago now. I can't remember, but I just wanted to show it again because I am still driving this car. And I show it because for a couple of reasons. One, it's an old car. It's a legacy car, so to speak. And two, I did get in a little fender bender. And instead of paying the money to do all of the body work and fix this particular vehicle, I instead went online to Amazon and bought a magnetic Band-Aid. And that was the best $12 I've ever spent. I like, solving this problem in this way. So I think we need to consider carefully the, how practical we are being with our processes, with our pipelines, with our development teams. Focus on the things that we actually care about, and those might be predetermined. Those might be determined by the budget of the project, for example, time constraints, various other things. These are items here that I've listed. Do you want your pipeline to be faster? Are you struggling with making sure that your environments are being set up quickly, that you're able to deploy quickly, that you're able to test quickly, all of that. Second is efficiency. How much time and effort are you putting into your processes to get your software out into production? Next, reliability. Do you need to focus more on making sure that your code is tested appropriately, that it goes through all of those stages, that you have the appropriate gates that your application must go through before it can be successfully deployed to production? The last one is economical, and I already touched on this one. How are you, with your resource usage? Are you storing a bunch of stuff in the cloud? Remember the old days? I'm going to date myself a little bit here. Remember the old days when we paid for every text that we sent on our cell phones? These are things that we need to consider now, at least temporarily, and maybe this will change in the future, but we're paying for every byte of storage now. And these are things that we need to consider, especially as we move a lot of our processes to the cloud and a lot of our artifacts and everything being moved to the cloud. This is a slide that it's very busy. I don't expect you to be able to read much of this. I just show it to show how overwhelming this landscape can be and all of the tool sets involved. everything that that is involved in your process from beginning to end. So at the very beginning, we're going to discuss where we focus on dependency management. That is what I'm going to be focusing on today. And there's several places in our pipelines where we need to pay attention to where we're getting our artifacts from. The first step is during development, active development, when the developer is involved in making sure that everything is coming into their local machine. So this means reaching out to remote repositories, public repositories like Maven. There's a question earlier about Spring, like how much is Spring represented in Artifactory, and I think that's a big question. But what I like to teach people is how to deal with their artifacts and their third-party dependencies that they're pulling in general. So on a local machine, the very first thing you do is you pull down your source code, you build that source code, and pay attention during that build process where your dependencies are coming from. So of course, Spring is a large framework. You need a lot of things to be pulled in generally from Maven Central. And what we teach is not only, once you pull those items in, you really should store them as they are. Keep them in your own private registries or repositories, whatever makes sense for you. This is going to be something set up like Artifactory. But whatever tool you use, make sure that you are managing those dependencies. This will help you troubleshoot in the future if you need to upgrade a particular dependency or you need to eliminate one entirely due to some vulnerability. These are all things that you can control with artifact management systems like Artifactory. So the next thing a developer does is push any code changes up to source control, and it would be nice to be able to trigger a build right then on a build server. Now, once again, that build server needs to have access to the dependencies. Are they using the same dependencies, the exact versions of those dependencies as they were in local development? That's something that you need to consider in your build servers. Make sure your build servers are connected to your artifact management system as well, and that your build servers aren't constantly reaching out to public repositories to pull these artifacts in. We often like to build projects without cache in order to make sure that we have repeatable builds. This means it's more important that you manage those repositories and make sure that you're getting the version you expect. Next, moving along on that pipeline, you finally get to deployment, and deployment is where you need to deploy your final artifact. Well, where is that artifact coming from? That's another reason to focus on paying attention to your artifact management system. So we go through all of these stages, these that I talked about. Obviously, there's a few steps in between here, but these are the ones that we'll be focusing on today. So development, we talked about that. Continuous integration in your build server, we talked about that. And then finally, delivery and deployment. As you go through each of these stages, make sure that you're paying attention to your original objectives. Are you fast enough? Are you efficient enough? Reliable enough? Or economical enough? These are metrics that you need to have in advance so that you know when you are doing well and when you need to find places in your pipeline to improve. Okay, let's go ahead and see this in action. I'm going to pass this off to Brian Bentz. He's going to give us the actual implementation of these details. And Pat, giving you the stage, Brian.
Cool. Thanks, Melissa. Yeah, sorry, I dropped out for a second there, technical difficulties, but I'm back. So what we're looking at here is a simple Spring Boot application. This is what we call BIT. It's our developer advocate mascot at Microsoft, and it's a beta feature. So basically, BIT is being displayed here, and I've got it linked to something called a feature. It's actually called app configuration. But it's also used, the term is used interchangeably with feature manager. So if I go into feature manager in Azure and I turn that off, whoops, it can connect to the service. It's just being coy. There we go. If I turn that feature off and I go back out here and I refresh this a couple of times. There you go. Bit's gone. Then I can turn that feature back on. So you get the idea. It's a feature flag, and you can actually control the application from inside the application using something external, an external switch that you turn things on and off. So that's the concept behind feature flags. Now, what else we're looking at here? This is the Azure portal. So portal.azure.com you go to, and you can sign up for free trial if you don't have one already. Otherwise, you're probably already familiar with this. I've got my portal organized into dashboards. So different dashboards for different events. You might organize it a different way based on your organizational needs. But for me, I've got this application here called JDConf test, and that's what we just looked at. Let me zoom in a little bit here. A JDConf test is an Azure app service, and it's totally scalable. In fact, I bumped up the scaling just for this presentation. This square here is called a resource group. So a resource group is where you organize all your stuff. So the first thing I do to actually create this application is I go in, I say create a resource. I go to web app, and I put in a web app name. Oh, first I pick my resource group, the one I just showed you, DevOps for Java Shops. I put a web app name. Let's call it May the 4th, because we have, oh, it's not available. Okay. You know, there we go. May the 4th is available. Okay. So .azurewebsites.net, it has to be unique. And then you can select a runtime stack. And of course, no surprise, we have .NET. We also have Java 11, 17, and 8 that you can use. I'm going to use the embedded web server, but you could use Red Hat, Apache Tomcat, etc. I know my region here is West US 2. As you can see, there's plenty of regions to choose from. When I go to deployment here, what I can do, this is the cool thing about this web app, I can enable continuous deployment. And this reaches out to my GitHub repos, and it checks to see which organization I want to use in GitHub. Then it loads all of my repos. I pick the repo that I want to use here, which is called DevOps for Java Shops, Test Azure, Test AB, nope, Test Feature Flags, JFrog, there's the one. So I can actually create this on the main branch. And what this does, it is actually generates some YAML. So if I go here, you can see the YAML it's going to generate. It's going to push this YAML up to my GitHub repo as a GitHub action. And on push, it's actually going to activate this. So every time there's a push into this repo, it's going to activate this particular GitHub action. Now, this is a GitHub action that's a generic action, and it's actually going to fail. And the reason it's going to fail, and the reason why I like to show this demo, is because I'm connecting to a service. You know, you can show a typical Hello World demo that everyone's seen standalone, but I like to connect to something because it's more real world, right? You might have a database, you might have something in this case, you've got a feature flag. So the feature flag connects, and you need a connection string to add that feature flag. So how do you actually add the connection string? I'm just going to close this because I already created one. We don't have a lot of time for this demo, so I already pre-baked this. Hope you don't mind. If I go into my repo here, there's a couple of things that I've actually updated. And here's the actual workflow that gets created for this. I added an environment variable here, which is a connection string. And the connection string, let me zoom in on that, is in my secrets. And I'll explain what a secret is in a minute. So the secrets actually connects to that connection string. You also have down here during the build with Maven step of this particular action, you do a Maven package and you refer to a settings.xml. And you have to pass the username and password for Artifactory as well. So this is another great demo because it shows how you can actually connect to an external service from your GitHub action, in this case, Artifactory. This is obviously you don't want a username and password put in something that's publicly available on your repo, right? So the way you fix that is you go into settings, and down here in secrets under actions, there are several secrets that we've set up. So this particular one is the connection string. First of all, that's the one I had before, and that's a secret connection string that I put that comes from that feature manager that I showed earlier when you click on and off that little checkbox. All right, then the host and the password for Artifactory and the username. And this is the published profile. So this automatically gets generated when you connect this to an app service. So that process I showed you about creating the web app, that actually creates this published profile. And that is a token basically that connects your GitHub repo to your Azure, connects your GitHub repo to your Azure web app. So that's secrets. The other thing we do, if I go into this one, is we have a settings.xml. Now the settings.xml would also have some information that you don't want to necessarily pass, sensitive information that in this case, username and password again. So you can use Artifactory username and Artifactory password. And if you recall, the reason why you can use these and the host, the reason why you can use these is because if I go back into my workflow up here, you can see that I actually created those environment variables. So this time it's not a secret, it's an environment variable. So I set up the environment variables, Artifactory username, pull it from secrets, password, pull it from secrets, and host, pull it from secrets again. And then basically after that, the build goes, and because the connection string and the published profile are working here, it creates a target jar file, app.jar. And from there, you can pick up a deployment task, which passes that jar file to your Azure web app, puts it in the right place, and runs the web app. If we look at the web app behind the scenes, JDConf test.scm. So there's, past tends to be a little bit of a black box, but we do have a way inside of Azure Web Apps to have access to some settings and some information in there as well. So hopefully it comes up. Let's try refreshing that again. Usually it's pretty quick. Yeah, welcome's not registered. That's fine. Here it is. So you can, for example, you can look at your www root file, and you can see that the app.jar is there. And you can actually download this and run this in applications or whatever. You just need to have that connection string as an environment variable as well. So that, in a nutshell, is how we actually build this application. And if I refresh it again, I enable that feature, so Bentz back. And that, in essence, is how you do it. So you go in, you generate the automatic YAML. Then once that YAML fails, because the first time it doesn't have the environment variable set up or the other string set up, you go in and update your YAML file for the workflow and your settings XML with Artifactory data. Once you've got all that and it runs, you can actually see in here, this is my JFrog platform, all of the artifacts that automatically get stored in Artifactory for me. In this case, we're using a snapshot, but there's a snapshot and a release. So releases are with Maven, things that you release into production with a version, and then the snapshots are by date. So there we go. That's basically how you set that up. I do also have inside of this repo, we'll share this link afterwards. Inside this repo, I have something called a provided GitHub workflow, which actually has everything that I've described set up, pre-configured for you. All you need to do is change this published profile when it automatically gets generated, and then I have an automatic settings XML here. And of course, as I mentioned before, we're using secrets, so the settings XML and the workflow don't have that sensitive information in them. All right. That's basically the demo. Melissa, do you have anything to add to that, or do you want to point anything out in Artifactory?
I guess one thing that is confusing for a lot of folks is understanding exactly where these artifacts are coming from. So when you're using open source which we all do, because none of us want to totally reinvent the wheel, right? We want to be smart about that, and we want to build bigger and better things. So we're constantly, using libraries that we are aware of or that we're familiar with. Spring is a huge one. So what Artifactory does for you is it provides you a proxy. So when you need to collect those artifacts, it will proxy that request out to Maven Central. And that's what Brian is doing today. He set up his project to point to his Artifactory instance. But when he asks for an artifact that Artifactory doesn't have yet, and he's pulling that out from Maven Central, that initial request is pulling that artifact in from Maven Central. And then subsequent requests are going to pull from that Artifactory instance. There's several reasons to do that. There could be performance reasons for doing that, also security reasons, especially if you are behind a firewall or something like that, and you don't have direct access to the internet and those public repos.
Absolutely. One thing I'll show you here just real quick in Artifactory. It's so easy to set this up. So you set up your Artifactory repo, then you say set me up. And there are two things you can do here, which is just basically, let me go back to Maven quick. What'd I do? I lost it. Maven. All right, so there's a deploy, and the deploy gives you a little snippet that you add to your pom.xml, which basically points to things. And this I created a secret for. And then configure here actually generates a settings.xml for you automatically. And it has usually your password and stuff in here, but not in this one. And then I put those in secrets as well. But I've already actually created that in the settings.xml. Once you've got all that set up, it just goes straight to Artifactory whenever that runs. As Melissa mentioned, if there's an update to any of those packages, they go into your repo, and otherwise they don't. That's it.
All right. Melissa, Brian, thank you so much for this awesome session and demos. It was beautiful to see a lot of YAML code. Thank you for that. So we are on time. So let me bring Josh Long. Josh, are you there?
Can you hear me?
Yes, we can. How are you?
Good. How are you?
Josh.
We are all good.
Right.
Where are you? Where are you?
Oh, sunny San Francisco. Somebody's got to be here. So I figured it'd be me.
Such a shame.
Could be worse.
Such a shame.
Yeah,
Could be worse.
life is tough. But hey, I'm good to see you all. I missed this.
Well, are you familiar with JFrog at all, Josh? Just by any chance?
So yes, first of all, obviously Spring, we're fans. But also my book, I wrote a book called Cloud Native Java, and they were generous enough to give me an artifact repository for that. So that was great. I even mentioned them in the book as a big shout out, because I was super appreciative of what they did to support that effort. And so yeah, thank you. Cloud Native Java artifactory.io, I think, or maybe it's jfrog.io these days. Yeah, I don't know.
JFrog.
Yeah.
Yes.
Yeah.
That's good.
They changed
That's
it
good.
at one point.
Yes.
What are you, Josh? What are you going to talk about? And Brian, Melissa, Brian, Melissa, what did you like Josh to talk about?
Oh yeah.
All the stuff Josh does always blows me away. So it's always amazing to see him live code all these things that he does using Spring. So I'm sure whatever he has got in store is going to be amazing. I can't even imagine what it'll be, but looking forward to it.
Oh,
Melissa?
thank you, Brian. The feeling is mutual.
Yes, I'm looking forward to it too. I had the pleasure of watching over his shoulder at a conference once when he was doing a live demo right then and there, just ad hoc. And man, yeah, he's an amazing presenter. Lots of information. Can learn a lot from Josh Long. And anyone asking about Spring, I tell them to go watch Josh Long's videos if they can find any online. They will learn a lot.
They can't. They'll learn soon, right?
I heard that if people search for Josh Long on the internet, there's a link to Wikipedia, but just redirects to start.spring.io.
Yes, that'd be so awesome.
Right?
That'd be good.
There's no point. There's no point in having a Wikipedia article. Just go to start.spring.io. All right, Melissa, Brian, thank you so much. I'll let you go. Have a wonderful day. All right, Josh. It's your show. You have 24 minutes now.
Oh, my goodness. Okay, thank you. Well, everybody, you can see my screen, I hope. Good morning, good afternoon, good evening. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, Java champion, and of course, I'm at your service. I am also the author of a book called Cloud Native Java, which is all about how to build resilient systems with Spring Boot, Spring Cloud, and cloud friendly. And the book is something on which my co-author and I worked long and hard. The cover, I think, is kind of relevant here. It's the animal, the bird that was depicted on the cover is a blue-eared kingfisher, which is a bird that is indigenous or native to the Indonesian Java island. So it's a bird that is indigenous to the Indonesian Java islands or native to the Java islands, and birds fly through the clouds. So it's a bird that flies through the clouds that is native to the Java islands. It's a cloud native Java bird, and that's the book about which I was just speaking with Melissa, Brian, and Bruno. Anyway, today, my friends, we're going to talk about building cloud native systems, and of course, getting to production. These days, where so often, indeed more often than not, production is a cloud environment, is incredibly important. Getting to production is something I think most people are struggling to do. They know that they need to get there quickly, more reliably, more repeatably, but they struggle with how. And they look for ways to make the process go faster. They look at technologies that can help them reduce the cycle time between concept to customer, right? And to repeat that process as quickly as possible. Speed in of itself is not what we want. Anybody can take a Ferrari and drive it straight into a wall at great speeds. That's not important. What we want is safety in that cycle time, right? How quickly can I take an idea, introduce it into production, learn from that, and then optimize accordingly, respond accordingly, right? How quickly can I be agile? And so people look for ways to do that. They look at continuous delivery and test-driven development and microservices and all these buzzwords from the last 20 odd plus years that really, if you think about it, their novelty is in their speed. It's not like we didn't have ways to deploy servers before. It's not like we didn't test software before. It's the cycle time that we're optimizing for. It's the ability to incorporate what we've learned in production and to improve upon that. One natural consequence of this struggle for this striving for velocity is that you look for ways to reduce the size of the code base, and that leads you to things like microservices. Microservices themselves are a consequence of your goal to go more quickly to production. They are not a technology pattern, right? It's more of a process pattern. It's more of a way of organizing your organization in such a way as to benefit from cycle time. By reducing the group of people working on a code base, you reduce the cycle time it takes to go through and incorporate all the changes to stabilize, freeze, and deploy those changes into production. So today, my friends, we're going to look at just a number of different things that you should care about in the Spring ecosystem that make building services intended for production more, make it go more quickly. So obviously, to get our journey started, we're going to go to my second favorite place on the internet. My first favorite place, as always, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring today. And what we're going to do is we're going to build a new application. We're going to use Java 17. Java 17 is the latest and greatest long-term supported version of Java. It is the least viable, but still viable version of Java that you can use in 2022. Java 17 is the right thing to do in 2022. There are other versions of Java on this page, namely Java's 11 and 8, which are non-choices. When I say non-choices, that's not just a type of Indian bread, my friends. That's a choice that you could make, but that you absolutely should never make. It's a choice that would serve you wrong. Instead, choose Java 17 because it is the latest long-term supported version of Java. It's robust. It's got more syntax, more features, more performance, more security. It's just a better choice technologically in every single conceivable way. It's also morally the better choice in every conceivable way. You will not like the look of shame and disgust in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. I'm a big fan of Java 17. And remember, if you judge only by the number of the version alone, then it's more than twice as good as Java 8. And so for that reason, if no other, you should choose it. We're going to add some technologies here that make building highly scalable applications a little bit easier. We're going to add the reactive support. Reactive programming is a way to build services that makes better use of I/O, and it lets you write code in such a way that your services handle much better scale while also being more robust and more resilient, I guess is the right word. So we're going to bring in the Springboard Actuator to give us support for observability. You saw Ryan talk about some of that being incorporated into Spring Framework 6, and we're going to bring in the, at the moment, experimental Spring native support. A lot of this work will also end up being in Spring Framework 6. So going forward, maybe in a year's time, if I come back, hopefully Spring Boot 3.0 GA will be out, and Spring Framework 6 GA, both of which are expected to land, as far as I know, sometime later this year. By that point, I won't need this. It'll just be Spring Framework 6. It just has it out of the box. Okay, so we're going to hit generate, and that'll give us a new service. And we're not going to spend too much time in the service. The goal here is not to linger too much in that. Let's see here. UAO customers.zip. We're just going to build a very, very quick service, something that has some data, something that we can work with very, very quickly, so that we can get to the business of talking about its production concerns. Okay, so this is just a brand new public static void main Spring Boot application, nothing all that special. I'm going to build an application that manages data of type customer, whose primary keys of type integer, and who's got a field called name. Okay, and I'm going to create a repository to manage instances of this type. Extends reactive CRUD repository. Here we go. And this is just an object. It's just an interface that'll handle data access, the tedious, soul-annihilatingly boring data access lifecycle logic. And I'm going to create an HTTP endpoint. So I'm going to call this customer REST controller. I could call it customer HTTP controller, I suppose. And we'll add customer repository. Okay, I'm just going to create a simple endpoint. I'm going to inject this into the constructor. And then we're going to create an endpoint to serve up that data, right? So customer get return this dot customer this dot repository at find all. Voila. Okay, there's my simple HTTP application. I need some sample data. Obviously, I'm using an in-memory embedded SQL database, and because it's in memory and embedded, it's going to lose all of our data every single time we restart. So we have to bootstrap it. So I'm going to create a file here called schema.sql, and I'll just say create table customer ID serial primary key, key name varchar 255 not null. Very good. And we're gonna have some data, just some sample data of people who are in the customer table. Let's see. We're gonna have Melissa, of course. We'll have who else? Jenna, Brian, Teresa, Bruno, Asir, I don't know. That's 7. Who else can I put? Did I already put Ryan? I don't think I did. And just somebody else. Who can else? I don't know. It doesn't matter. Jurgen. There we go. So there's our sample 8 names. It's a nice round number. If you divide it by 2 and then 2 again, it's still 2, which makes it easier to sleep at night. Good. So there's our application. Let's go ahead and just spin this up and see what that gives us. I'll take some coffee. I think I've earned it. Okay, so localhost 8080 customers, not there we go, customers. Voila, it's worked great. Now that's not all that I wanted to talk about. Indeed, what I really care about here is what this looks like in production. So first things first, I'm going to want to support observability. And to do that, I'm going to use the actuator. The actuator exposes a number of HTTP endpoints that surface information about the application. Because remember, in production, nobody can hear your application scream. You have to give it the ability to articulate its own state so that it can work in cooperation with your cloud technology, namely things like Azure Spring Cloud. And it surfaces health information. It surfaces a whole bunch of other stuff there. So localhost 8080/actuator, voila. And you get all these managed HTTP endpoints, your health endpoint, your info endpoint, conditions, your environment, metrics. This is powered by Micrometer. Ryan spoke about that as well. That'll be further integrated in Spring Framework 6.0 later this year. So just good stuff. We got observability. We got the health endpoint. We got information you can use to identify the service, etc. Very good. Now, I want to take this to production. Obviously, I have a public static void main Spring application with some sample data in it. Not all that impressive, but it's something. I want to go to production with that. These days, there's 2 things I want to take advantage of. One is I want to take advantage of native image compilation. So Ryan and Bruno, I think, spoke about that to some extent earlier on. We're going to take advantage of GraalVM. Now, GraalVM was originally an open JDK drop-in replacement that had its own custom hotspot replacement, which is great, but that's just-in-time compilation. If just-in-time compilation is so great, why not proactively do it ahead of time? And that's what you get when you use the native image compiler in GraalVM to ahead of time, to before you deploy the application, to compile the whole thing into native code. The only problem with this is that GraalVM hates your code a lot. I mean, the native image compiler hates it a lot, right? It wants your code to fail. And so as a result, it throws away all the stuff your application is going to need that it doesn't see at compile time, right? So things like types that you reflection on, proxies, jar resource loading, all these kinds of things that it cannot deterministically see for obvious reasons because nothing could. It throws that away, and the problem is you have to tell it about that. Well, if you don't tell it about that, it's going to try and create an application that's a native image that is lacking in all this stuff, and your application is going to start and then immediately fail because it's going to miss a type or miss some types that it's going to do reflections on or whatever. So you need to provide that configuration. Spring Native is a project that we created that provides all that configuration to the GraalVM compiler for you because it knows about the common patterns typical of enterprise Java workloads, right? Because of Spring. And so that support is already there. You can see it's here. I didn't have to do anything besides add Spring Native at the Spring Initializer. It's going to compile the application and turn it into a native binary. Now, obviously, I'm on a Mac as we speak, so this native binary isn't going to work particularly well if you're trying to deploy it into a Linux container. But that gets us to the next point, which is build packs, right? And Bruno and Ryan, the portmanteau of which I guess is Brian. Ryan and Bruno spoke about build packs a little bit earlier as well. It's a great technology that allows you to take your application and turn it into a Docker image, a container. And it's just supported out of the box. I don't have to do anything special here. It's already pre-configured when you have the Spring Boot Maven plugin on the class path, as we do. And it'll just create a Docker image for you, and then you can Docker tag and Docker publish that image. If you are using Spring Native, it'll run it'll create a Docker image with a native image inside of it. So it'll compile the code in the Linux container, create a native image in that in the builds phase, and then the container that you get is the Linux binary in the Linux container that you can then Docker tag and Docker publish. Even better, if you're using GitHub Actions, thank you, Microsoft, you can do cross-compilation because there's a GraalVM plugin that you can use. So you can actually do, a matrix build for Mac, Linux, Windows, whatever, right? Okay, so here's just a regular binary. I didn't bother doing the Docker container, but you can see this is going to go a little slow the first time because it's going to ask for permission. So hit that, okay. Control C, voila, there you go. So there's our application. It's up and running. It takes 77 thousandths of a millisecond. It takes about 100 megs of RAM for the entire application, not RAM, for footprint and RAM, yeah, basically. I'm on a Mac. It's actually less on Linux for reasons I don't quite understand. But anyway, just try it out. There's your native binary. So now we've got a native binary that starts up in no time at all, that takes up no footprint, no space, no nothing. I want to build an edge service. I want to build something to talk to that. So I'm going to return to my second favorite place on the internet, and we're going to build an edge service. And here, we're going to use the reactive web support. We'll use Spring Cloud Gateway, and we're going to use Spring Boot 2.7.0 milestones, or RCs. That's imminent, right? I think next month. It's a 6-month release cadence. So by that math, I think it's next month sometime, or maybe this month. No, probably this month actually. We're in May already. And we're going to use GraphQL. Yeah. So I'll bring in these bits. We're going to go ahead and use Java 17 again because it's the right thing to do. And we're going to go ahead and hit generate, and that'll give us a new application. And this is going to be an edge service. It's a service that you can use to act as the intermediary between the outside world and the downstream services. Your microservices, your service that we've just built, for example. So let me see, Maven, clean package. This is a great time to do this right now. What is happening? Spring Forest. I don't care. Okay, you know what? We can just skip the gateway bit. The time it's taken to figure this out has cost me the time it would have taken to use that. What is going on here? I don't care about that. Let me just remove the bomb. Something weird right now. I don't care to figure it out. Nope, not that. That's a good one, but not what I wanted. Clean package. Go team. All right, good stuff. Okay, so I have a brand new application. Apparently, they did a release in the last few days that I just forgot to do a Maven sync on. So this edge service is going to sit as the first port of call for requests coming in from the outside world. It's a great place in which to handle incoming requests and to forward them to the downstream service. One way you could accommodate those incoming requests, because there are going to be different kinds of clients, right? iPhones, iPads, Androids, all these kinds of things. One way to accommodate those different kinds of clients is to transform the requests at the edge. And you could have proxied them. You could use Spring Cloud Gateway, for which, by the way, we have a commercial thing for Kubernetes if you want. But you can also just use the Java API, which is what I was going to do, but for some weird oddity there in the resolution of the package. And so Spring Cloud Gateway is an API gateway, very, very convenient. Or you could build some Java code to talk to your downstream services. In Spring Framework 6, we're going to have a generic mechanism that looks kind of like Spring Cloud OpenFane or Spring RetroSocket or Spring Cloud Square, retrofit support. All these interface-based declarative clients all have a common goal, which is to make it so that you can define an interface and automatically get a client that will make RPC calls basically to your downstream services, be they HTTP or RSocket based. Well, that mechanism has been spread across different implementations, different foundational pieces. We're going to converge upon one abstraction, one mechanism, and the core Spring Framework 6 framework, and on top of which we'll then build these different clients. So that'll be in Spring Framework 6, and you could use that here as well. You can also write the code manually. So that's what I'm going to do. I'm going to build a CRM client that'll talk to our little HTTP customer service. And this is going to use the HTTP client called the web client. I'll add this to the constructor. It's going to be a regular Spring Bean at component. And it's just going to return the data from that customer service. So customer, and it's just a record. And of course, same idea. I'm going to create a DTO, a struct. This is something terrible, something you should never ever do. I basically just copied and pasted code from one thing to another, which is terrible. Don't ever do that, not even at home when nobody's looking. And we're going to get the customer data. Yeah, so I'm going to say return this.http get URI HTTP localhost 8080 /customers retrieve body to flux customer.class. Okay, there's the data. Now, obviously, this might fail, right? Network services sometimes fail. So you can do retries. You can say retry dot back off duration of seconds, whatever. You can do on error resume, and when there's some sort of exception, you can return an empty stream instead. You can do timeouts. You can do all sorts of things. And notice that these operators that I'm using here are part of the reactive API. This is not specific to HTTP or RSocket or whatever. So anything that speaks reactive, you can use these retry when and on error and timeout and all that kind of stuff. Okay, so I've got now a client, and I can use that to create a simple endpoint, class CRM REST controller. And this is acting as a kind of a proxy, as a pass-through. You could also do composition, reactive service orchestration composition by calling other network services. Reactive programming is great for doing that kind of stuff. And so here I'm just going to say get mapping customers. This is let's just say that, and we're going to say publisher customer get. Okay, and I'm going to inject again the customer repository there. Sorry, not the CRM client. So remember, we're acting as a client to the downstream service because the goal here is to provide a view of the data. In this case, I'm not really doing anything to the data in particular, but the goal here is to provide a view of the data that accommodates a particular client. And that client could be an iPhone, an Android device, whatever. And they might have different bandwidth constraints and so on. So you don't want to make them make different calls to different network services, right? You want to do that on the server side. So I'm doing that here for the client, so it doesn't have to do that on its side. In order for this to work, we need an actual HTTP client. So I'm going to build one here like so. Return builder.build, voila, restart. There's my HTTP client. I can just as easily build a RSocket client. That's fine. So localhost 9999 / what did I say? Customers. Internal status 500 customers. Come on. This.crm localhost. Did I not start this up? This is up and running, right? Looks like it is. So let's just make sure localhost customers. There it is. 9999 / customers. That's not working. Why? Let's see. Localhost. Actually, better yet, just go with what you know. This didn't work. 8080. Okay, paste that. Is there anything different here? Body to flux, retry, timeout, customer, multi-value reactive types not support. People. This is a component, but the kind of controller I'm building is a regular REST controller, not a view controller. So response body, restart that, voila. Okay, so that'll give us our client-side representation of the data. You can use reactive programming to get around, that's 8080, here's 9999, great. That said, I've had to create a simple reactive API to accommodate the view of the client. And this happens all the time, right? You might have an Android client that wants only just certain data, and you don't want to call the whole service. Maybe you want to whittle down the payload of the data. Maybe you want to like just return some part of it. Maybe you want to get data from over here and compose it into one thing. So reactive programming makes that kind of stuff very easy, but it's still code that you have to write. It's still work. And I'm all about not doing work. I mean, look at me. Do I strike you as the kind of person that does work? No, I think not. Instead, what I want is to have some way to have my cake and eat it too. And this is, I think, the same bind in which Meta, nay, Facebook, found themselves back in 2012. They had disparate services, but they wanted those services to be isolated. They wanted their encapsulation, but their clients wanted everything in one fell swoop, in one big gulp. And so they had to sort of make that tension work. And they created something called GraphQL. Now, GraphQL is a really interesting technology. So source main resources, I'm going to go here. I'm going to create a new folder called GraphQL. And in that, I'll create a new file called, let's say, crm.graphqls, okay? And in GraphQL, you create a root type called a query. That's the first type where all your client tools are going to look to inspect all the different endpoints that are available. And I'm going to define a field called customer, right? This in turn expects a type called customer. You can see that this is a one-to-many value. I've got brackets. That means there's more than one value. It's not a scalar. There's more than one value there. This in turn will have an ID and it'll have a name field. Voila. And so I can return that data. Now, of course, I could also put other fields here that don't necessarily line up with the representation of the type in my Java code, right? So just because my Java type has ID and name, that doesn't mean that the GraphQL representation needs to. And indeed, I can have all sorts of other things. So let's go ahead and create a new controller here, Crm Graphql Controller. And this is going to also use my Crm Client, CRM. And we're going to create a new endpoint here. And the endpoint is going to implement this query type. It's going to be a schema mapping for the type called query. Query. And the field name is called customers. Yeah. So I'm going to return a bunch of customers for that type. So when somebody tries to resolve that field for that type, we'll just call this method here. Okay, very good. Now, it turns out that this is a very common thing. Like I said, this is a well-known type, query. You can have your own custom types, but all GraphQL projects will have a query type and possibly a mutation and possibly a subscription type. And because it's such a common thing, we actually have a semantically more interesting annotation called query mapping, which is a specialization of query mapping with the type name pre-filled out to query and the field derived from the name of the method. So this is semantically exactly the same as that. This is just a notational convenience for that. Let's go ahead and run this. But in order to kind of see what's happening, we need to enable a little graphical console, right? And this console allows us to query our GraphQL engine. Let's go ahead and restart. Port 9999, localhost 9999/graphical. Get it? Graphical. There we go. And now this is a little console you can use. You might have recognized it from other people that use GraphQL. So GraphQL, I mean. So for example, API, SpaceX is a spacefaring company that, I don't know, whatever, they do stuff. And they have an API you can explore, for example, to see, what's happening. And the nice thing about this is you can just ask questions and you only pay for what you use. So let's say I wanted just this data, right? I don't want that. There you go. So I'm asking for just the just the mission name for the last 10 launches. And I want the capsule information. No, thanks. So I just want that. Great. I only get that back. If behind the scenes there are other services that would have been involved in producing the response that has all this or whatever, that's different. I don't have to pay for that network call, that service orchestration and composition call if I don't want it. I get back what I pay for, okay? Okay, so here's my API. Whoops, I actually did a screenshot. Do a query there, and you can see I get introspection. I can just control space my way to production there, and I can make requests, and I get back what I'm expecting as GraphQL. So this makes it very easy to have a uniform API, one big API that in turn federates all the other APIs and makes them available to the consumers that need them and in the shape that they want it to be. If you don't want the data, if you don't want the name data, great, you don't pay for it. You just get that back. And this is very useful. This is kind of useful here, but it's very useful because you can have, let's say your customer has a type profile, okay? So I've got now a new type for that called profile, and it just has an ID. And that might be another microservice, right? So here I can say schema mapping type name equals customer, and I can build another type. And let's suppose I'm making another call to another microservice somewhere. I'm not going to actually do it, but you can imagine how that would work. I can now say profile for the root type called customer, right? So I can say return new profile, and the profile will be, whatever, the same ID as the customer. So this could be a network call, is my point. So this gets invoked, this method gets invoked to resolve that profile only if somebody asks for that profile. And this is one of the nice things about GraphQL is you can have your cake and eat it too. So let's refresh this, paste, and now there's my customers. Did I forget to add that? There's the type. Oh, it's called type. I should have called it profile. But okay, type. So if I ask for the type, I get that back as well, right? Oh, there's nothing. Let's see. That's because I named the method wrong. I named it profile instead of type, which is what it was originally. Just restart here quickly. Very good. Rerun. Come on. Customers type. No, profile. Voila. Okay. There we go. There's my data. So there we go, my friends. There's a number of different patterns that you can look at to easily build services that scale. You can use reactive programming to make your services more robust in the face of production outages and service topology changes, to be more scalable, to be more resilient. You can use things like the GraalVM native image support in both Spring Boot 2.x and Spring Boot 3.x coming up to make to turn them into GraalVM images that perform in lightning fast, super fast speeds with very, very small footprints. You can use build pack support to build Docker images that you can easily just take to production. You just say maven spring-boot:build-image. And of course, you can build edge services using technologies like Spring Cloud Gateway, for which it turns out we wouldn't have had time anyway, using GraphQL and using reactive APIs to make your services more robust and more accessible to the consumers. And obviously, all of this goes to production very quickly. You can use things like JFrog for your artifact management, and you can use things like Azure Spring Cloud to take these binaries and get them up and running in no time at all. I didn't even get a chance to show you things like centralized configuration using the Spring Cloud config server in Azure Spring Cloud, or service location and discovery using the Spring Cloud Eureka support already pre-provisioned for you in Azure Spring Cloud. There's so many more things we could have talked about, but I'm afraid, my friends, we're just about out of time. Thank you for your time today. I hope you have a great day, and I'm happy to answer questions if there are any.
All right. That was amazing, Josh. Thank you so much. That was like...
Thank you.
Was that a first, 25 minutes session?
No,
today?
but it's definitely the first one today. Absolutely the first one today. I haven't done any of them today, so...
Awesome. It was amazing.
Fun. Thank you.
I was watching the comments and people were in love with it. I would like to invite James and Jason, our next speakers.
Hey, everyone. Hey, Bruno.
Hey, James. How are you?
Good. How are you?
Yeah, I'm good. We lost Josh. Josh, if you are still around, come back to us. If you're not, that's okay. That's okay. I think I forgot to tell him, stick around. So that's fine. We only have 2 minutes anyways. You guys have to start in less than 2 minutes now. Hey, Jason, how are you doing?
Good. Hi, Bruno. How are you doing?
Yeah, I'm doing great, man. Where are you guys based? James, where are you based?
I am in Orlando, Florida. I actually live in the Cinderella Castle, right at the top there.
Orlando, Florida. Yeah. that horrible weather of yours. Thank you. Very comparable to Canada's. Jason, whereabouts?
I actually just moved. I was in Redmond for a couple years, and then my fiance and I just moved down near San Francisco, closer to family, both of ours. So a little sunnier than Redmond, I'll admit.
I don't know how to deal with this. Both of you with the worst weathers of North America. I cannot cope with that. But Canada treats me well, okay? I cannot argue with that. I love it. And I also love Florida, especially when I have to go to Disney to please my wife and kids. And Bay Area, because the Golden Gate is awesome. Golden Gate Bridge is awesome. Well, thanks for being here. We have, what are you going to talk about? Can you give a sneak peek?
Yeah. Sure. So, go ahead, Jason.
I can take it, sure. Yeah. So today we're going to talk about Java EE and some of the locations where you can run that on Azure.
All right. So
customers who are already in production, Josh was mentioning getting to production, already in production. Now they want to make it faster and cheaper and better.
Okay. So talking about existing Java EE applications. I mean, Josh spoke about creating new applications, start.spring.io. I don't think there is like migrate.java.ee kind of website, right? It's something that requires a little bit more, but that's where you're going to show how can be done, right, with existing technologies and Azure services. All right, so we are on time. So thanks for being here, and yeah, you can get started.
Okay, great. So hi, everyone. Thanks for joining today. My name's Jason Freeberg. I'm a product manager on Azure App Service. And today I have the pleasure of being joined by James Faulkner, Director of Product Marketing at Red Hat. And in today's session, like we mentioned, we're going to talk about migrating and modernizing your Java EE applications with Red Hat Jboss EAP on top of Azure App Service. So if you have any questions, feel free to post those in the chat as we're going through this. But without further ado, let's talk about Azure. So as you might assume, there are a lot of options for hosting and running your Java applications on Azure, and it all depends on where you want to land on the control to productivity spectrum here. So of course, Azure has infrastructure as a service. You can use virtual machines on Azure or virtual machine scale sets to host your Java applications. And if you're not familiar with that term, virtual machine scale sets, that service is a infrastructure as a service offering that allows you to scale your applications out to thousands of VMs. But as we all probably know, virtual machines and raw infrastructure comes with its own level of management and configuration versus some other options out there. So if your organization uses containers, you can use a service like Azure Kubernetes Service or the joint service Azure Red Hat OpenShift. And in both of these cases, it'll provide a few more productivity features to allow your organization to achieve more and probably get to production a little bit more quickly. Now, going even further up and to the right, if your organization does not want to be in the business of managing virtual machines or in the business of orchestrating containers, there are services like Azure App Service, which we'll be talking about today in this session. And there's also Azure Spring Cloud, which Josh Long just mentioned in his session. And both of these services provide a managed platform for deploying your application code or containers. So in today's session, let's take a closer look at Azure App Service, and let's start with deploying, because deploying your application code is often the first step in trying out a new compute service. So like I mentioned, with App Service, you have the option of deploying your application code, or you can also choose a container. So if you're deploying your application code, that will go on to a container image that Azure App Service will manage and update for you. But if you're already using containers and you have a registry, you can simply point to the container image and then App Service will pull it down and run it just the same as if it was a managed image on the platform. So for deploying code, App Service provides APIs, plugins, and extensions to deploy from a whole host of client tools like you're seeing here. We have plugins for Maven, Gradle, GitHub Actions, Jenkins, Azure DevOps, and probably more that I'm forgetting. And so you can use those tools to set up a CI/CD pipeline to continuously deploy to Azure App Service. If you go to the Azure portal, you can go to the Deployment Center, and then from there, App Service will help you set up a CI/CD pipeline from GitHub or Azure repos. On the other hand, if you already have a CI/CD pipeline and you want to continue using that system, then you can use tools like the Azure CLI or the Maven and Gradle plugins, and you can use those tools to deploy as part of your existing pipeline. Now, once you've deployed your code onto Azure App Service, there's a feature called deployment slots. Now, this feature is essentially independent staging environments where you can deploy a new version of your application, or you can test new configuration changes. You can deploy pull requests there. You can also use it as a QA environment, things like that. And when you're ready to put that new build of your application into production, or if the new configuration changes are looking good, then you can swap your staging and production environments. And so underneath the hood, when you swap those slots, App Service will scale out your new staging environment before it goes into production. So that way you're ready to meet any production workloads with that new build. Then once you've deployed your code onto App Service and you've set up deployment slots, you can then secure your site on app service with all of the networking features that Azure offers. So you can deploy your web app into a virtual network, and that will secure the connections between the Azure web app and other resources, such as a database, a cache, or a messaging service. And then you can also use ExpressRoute, which we're seeing here in the bottom of the screen, and that allows you to connect to on-premises resources. Since we're talking about migrating and modernization, you might have some dependencies on-prem that you still need to connect to. So Azure has networking features to enable that. Then once you've set up private endpoints, you can use that feature to isolate your application from the public internet. And that's great for internal facing applications if you don't want your resources being accessible to the public internet and you only want them facing internally. And then there's other great features too in Azure networking, like Azure Front Door and Azure CDN, to give yourself more points of presence for your Azure web app. Then once you've set up networking and secured your site, you can also set up rules to automatically scale your deployment vertically or horizontally. So you can scale up to larger VM sizes, or you can scale out horizontally to more VMs. And you can set up those rules based on a whole bunch of different metrics, like request counts, CPU or memory consumption, or simply by the time of day if you wanted to scale up during business hours and scale back down during off hours. Now, when you're scaled out to multiple instances, App Service has a feature called Health Check, and this will ping all of your independent instances. And if any of them are unhealthy, they'll be removed from the load balancer. So that way they're not responding to end user requests. And if they become healthy again, then they'll be brought into the load balancer to continue serving requests. Then when you're scaled out to multiple instances handling millions of requests, monitoring becomes very important to monitor all of that infrastructure. So thankfully, App Service integrates directly with Azure Monitor, which is the Azure native monitoring solution, and it provides a turnkey monitoring solution for your Java applications. So that means there are no code changes required. All you have to do is enable application insights from the Azure portal or the CLI, and then the service will attach the monitoring agent to your application for you, and the metrics will begin flowing into application insights. When this is enabled, you can use application insights to watch live metrics, which is what we're seeing here on the screen. And you can also view an application map of your entire deployment. And then you can set up alerts for scenarios like slow or failing requests and get a text or an email alert. And then you can use application insights to diagnose and solve that problem. So talking about Java on App Service, we've actually had support for Java since 2014. You can deploy applications with an embedded servlet, so something like Spring Boot or Quarkus or MicroProfile or anything that runs as a .jar application generally. And you can deploy that to Java 8, 11, or 17, and we use the Microsoft build of the OpenJDK. On the other hand, if your application runs on top of Tomcat, we do have a managed Tomcat runtime where you can deploy your war applications. Over the years, though, we've heard from our customers that they wanted a similar hosting option for their Java EE applications as well. And so that's why we've partnered with Red Hat to offer Jboss EAP on top of the Azure App Service platform. So this means that you get all the features I mentioned earlier, like easy deployment APIs, networking features, auto-scaling, monitoring, and everything else that's offered as part of App Service is also available for Jboss EAP on App Service, since it's offered on top of the platform. And even better, this is a jointly supported offering from Red Hat and Azure. So that means you get full stack technical support from both companies. If you run into a problem or you have a question, you can submit a support case with either company, and then behind the scenes, the support engineers from Red Hat and Azure will collaborate to resolve your case. And this is by default. All Jboss EAP apps on App Service are automatically enrolled into the joint support program. And you don't need to secure a separate support entitlement from Red Hat. So without further ado, I'm going to hand it off now to James Faulkner to walk us through an exciting demo of Jboss EAP on Azure App Service.
All right, thank you very much, Jason. Fantastic to see all those awesome features, apply to Java EE, Jakarta EE applications that have been in production for 2 decades. Really, and having the ability to move those easily to the cloud with Azure is a nice offering. This is the new offering that we launched last year, Jboss EAP on Azure App Service. So what I'm going to demo today is taking an existing production application on-prem and migrating it to Jboss EAP on Azure App Service, and then exploring a few of the integrations that we've also worked on with in partnership with Microsoft to really enable a traditional Jakarta EE application to take advantage of the modalities of cloud deployment, cloud development, and the scalability and reliability of Azure. So I'm going to start here on the Azure portal, and this is where you create new web apps. Brian earlier demoed creating a generic Java web app. We're going to go ahead and create a Jboss EAP web app by clicking Create Resource. Same thing here, click Create under Web App. And under here is where you enter the resource name, the resource group name, the web app name, and some other information. There's also a new experience you can try out. I'm going to use it today because my existing Jakarta EE application relies on a database in addition to the business logic. So I'm going to use this experience to create the database and the web app very quickly. So you can pick a new resource group. I'll just call it JHF Test. Give it a name, JHF Test Web App. And then you'll pick a runtime stack. Now, in this case, Josh mentioned Java 17 is the only way to go. Well, it's currently the only way to go for about 10% of the Java ecosystem. We're happy to see the increase, the numbers increasing on Java 17. We are adding support for Java 17 in the Red Hat stack as well. But the vast majority of our customers are on either 8 or 11. So I'm going to go with 11 here. And then here I can pick Jboss EAP 7. And that's really the only difference between deploying a generic EAP or generic Java app versus a Jakarta EE app with EAP 7. I can also specify the database name here. It'll automatically create a flexible server using Postgres. I've already created this. I've actually created a number of different environments, cooking show style, since we have a limited amount of time. So I would normally click Review and Create, and then go ahead and create that. So what that's going to give me is a web app running Jboss EAP. So I have this under JHF Web App 1. So this is my first web app. It doesn't have any actual application deployed to it, but it is a running web app instance. You can see here if I access the home page, there's a default landing page. So this is where we're going to deploy our application. So the application that we have running in production today is over here, and I've loaded it into my VS Code IDE. This is actually a WebLogic application. You can see several of the classes use proprietary WebLogic APIs. To run this with Jboss EAP and Jakarta EE on Azure App Service, we need to move away from these APIs and move to the more standard Jakarta EE APIs. And so what Red Hat has created over the last 20 years of working with our customers is a toolkit, a tool set of reusable rules that can automatically analyze your source code and identify issues like proprietary use of APIs or things that aren't cloud ready, for example, hard-coded IP addresses, local file system access, things like that. This tool is called the Migration Toolkit for Applications. We have a number of other toolkits for migrating containers and virtual machines as well. This particular application migration toolkit also has a VS Code extension, so I've loaded that into my IDE here, and I'm going to go ahead and run the analysis. So I'll configure my analysis with a target of EAP 7, which is the version of EAP that's supported on Azure App Service. And then under the source, I will pick WebLogic here. I've also entered the source code folder in which the source code exists, so I can simply right-click and say Run here. And it will take about 30 seconds to run it. So what it's actually doing is it's taking those rules that we've identified. Over the past decade, we continue to identify new rules where we found customers migrating applications. We've encoded those into this tooling. So this tooling is applying that rule set based on my source and target to my source code, and it's going to generate a report that says okay, here you're using non-standard APIs. Here you're using local file system access. Depending on the source and target, it applies a different set of rules for analyzing and allowing you to do a migration. Now, this tool is useful for an application, but it's really useful when you're doing 100 or maybe 1,000 applications, and you need to know the relative level of difficulty of migrating these applications to the cloud, so that you can, say, assign your junior engineers to the easier applications, and assign your more experienced engineers to the more difficult migrations. So using this tool, you can do that analysis and assessment of your applications and kind of get a really great idea of how long a migration is going to take, and how hard it's going to be. So I've opened the report here. Let me open it up in my browser here. If I click here, so this is the report that gets generated, and you can see it assigns this thing called story points. These are the relative level of difficulty. So if I had multiple applications, you'd have multiple apps listed here with the different story points. But this one happens to have 11. Click on the name of the app, and I can get more detailed information, class by class and package by package of what happened. If I click on the issues tab, I can see the exact issues that it found. For example, it found the usage of the WebLogic proprietary logger in this particular class, in this particular line, and it kind of gives you guidance as to how to fix that. So this is a relatively easy one. There's a few other issues that it found in here. I'm not going to go through them in the interest of time, but what I will do is fix the application. So I'm going to go back, and you can see in the IDE, it kind of shows you, if I click on Startup Listener here, you can see one of the other issues that it found, which is a proprietary use of non-standard application lifecycle events. So I'm going to go ahead and fix that. It's a pretty simple fix. I'll just paste the code in here. And basically, you can see the diffs here in Startup Listener, where it replaced the WebLogic APIs with the standard JavaX, now Jakarta packaging names, and then changed the annotations to match that. So very easy to fix that file. There's one other file I need to fix real quick, which also uses a logging API that's not Java EE standard or Jakarta EE standard. That's in the promo service file. So I'll go over to the promo service file. You can see it's also marked here. So I'll just fix that, and bam. So I've got my application now migrated. So if I head back over to the tool and rerun it, we should hopefully get a 0 for the value. Again, this migration toolkit's really useful for a handful of applications where you really need to get a good sense of how difficult a migration is going to be, what's in your applications on your corporate applications. It also is extensible, so that if you find a specific use of some API or specific pattern in your applications at your company, you can encode that as a rule. You can use that in your CI pipelines to check the progress of a migration, or you can even contribute those upstream if they're applicable to the larger Java ecosystem. So this should be complete here in a few moments, and if we reload our the report, once it's done, hopefully we'll have a 0 here. Let's see how close we get. Finalizing, and drum roll.
I wish I had a soundboard.
Okay, so let me open the report back up in my browser here. Go back over here, reload, and I have 3. So I missed something. What did I miss here? Oh yeah, I forgot to delete the. There was a specific WebLogic EJB jar.xml file specifying the transaction timeout. That's actually handled in code now in the application, so I'm not going to worry about that. Jboss EAP won't read that file. We'll just go ahead and assume that I just removed that file, and it will then be correct. So with my application migrated, I'll just go ahead and build it just to make sure that I didn't make something I shouldn't have. Yeah, so it looks like it's done, or will be done here now. So another nice thing about Azure App Services has a number of extensions and plugins that Jason mentioned. One of them is in the Azure plugin for VS Code. So I can actually load my, I can see my web apps here. I have JHF web app 123. I'm going to basically deploy my newly created web app, my WAR file, to this web app, and it will go off and deploy that automatically through the plugin, and set deploy, And once it starts, so I've already deployed it. So it'll build it and then it'll automatically deploy that WAR file. We're not going to wait for that because I've already deployed it into my second web app here. So I'm going to go back to my web apps to JHF Web App 2. So this is what you get once you deploy the application, whether you do it through the Maven plugin or through a GitHub action, which we'll do later, or through Azure or through the VS Code plugin, it will get deployed and it will get automatically brought up. And so here's my new application. This is a retail store application, very similar API to any other retail stores you've seen on the internet. It's got a number of different services using standard Jakarta EE APIs like EJBs and CDI and REST and lots of stuff like that. So this application also, as I mentioned, uses a database. And so as part of my application, if I go back to my source files, you can see that integration there. What we have is a set of Jboss CLI commands. This is a Jboss ships with a CLI that lets you automatically create data sources. We've automated this so that it's repeatable, and every time our app service starts or restarts, this database driver and data source is there for the application to use. And you'll notice it has a number of variables there, so I don't have to re-specify them for every different environment. We use environment variables there, which are then passed from app service. Let me show you that. So under configuration, those variables are declared here. So depending on which environment you are, you'll have the different values here, which then get replaced. And so the application can get connected to its Postgres database automatically. So that's kind of nice. So now with my application up and running, now I want to turn my attention to CI. And we have about 4 minutes left, so I'm going to go kind of fast here. So what we want to do is configure this for GitHub Actions so that every time a change is made, it'll automatically deploy those. So I'm going to go to Deployment Center. I'm going to link this with my GitHub source code. So I'll select GitHub here. I'll choose my organization, which is me. My repository is going to be the workshop repository, workshop. And I'll choose a branch of choose main. And it automatically detects all the things, Java 11, Jboss EAP. You can get preview. You can see what it's going to create. It's going to create the same thing that Brian created earlier, except this is specifically going to use the Azure Web App Service integration with GitHub Actions to deploy that. So I'll go ahead and click Save. And so what that's going to do is create a GitHub Actions runner file in my source repository automatically for me. It's also going to set up the credentials so that it can easily keep those secret, using the same mechanism Brian showed earlier with GitHub Secrets, and it's going to automatically push that every time I make a change. So if I head over to the actual repository, you can see here, if you go over to Actions, you'll see a new action has started to run, and it will build and then deploy that all the way to my app service. So very easy to set that up. So the last thing I want to show is the metrics and observability integration with Application Insights. So heading back over to the code, Application Insights gives you out-of-the-box stuff with Java. But it also allows you to do customized metrics. So for example, in my product service, say I want to add a mechanism to automatically expose a metric of how many times an API has been accessed via micrometer. So I'll create a counter. Counter equals metrics.counter, give it a name, get product counter, and then I will actually use that counter. I need to import the metrics class here, very easy to do. And then under my get products, I'll just say counter.increment. Go ahead and rebuild that and then redeploy that. If I open my terminal, Maven clean package. So just to make sure it kind of builds here. So what I'm going to do now is actually commit this code to my repository. And what that should do is kick off another build, deploy this application out. So if I go over to my source repository, add counter, and yes, I will commit it. Sync changes. This is going to push that code up to my repository. So if I head back to my browser, get over to my repository, you'll see a new action beginning. So we're not going to wait for that to complete as well. I've created a third environment which has this already deployed. So if I head back here, go to Web App 3, you can see I still have my application up and running with Web App 3, but I can also do things like in the where is it? It's hard to find sometimes. Okay, application insights. So if I click on view application insights data, I can get, like I said, default kind of server response, failed requests, availability status, but I can also get metrics. So if I head over to the metrics here, and I can choose to select default JVM metrics or OS metrics, but I can also hopefully find my my custom counter here, this get product counter. You can see I've got a thing running in the background that's accessing this. So you can automatically see that. You can also do things like look at the application map to see your application. In this case, it's a single application pointing to a single database, but you can imagine, if you had a more complex application with multiple components, you can kind of identify that and visualize that. You can also get logs and look at, SQL queries and things like that to identify some of the challenges that you may have. So you can see some of the SQL calls that have been made here, like this one here. Kind of shows the graph of a distributed graph of these calls that are being made within my application. So very powerful, very easy integration, very easy to take an application in production on premise today, move it to the cloud, shut down your data center, and still keep running with Jakarta EE and Jboss EAP. So that's it. I'll pause here. Yeah.
Flawless. The demo gods are really in our favor today, huh?
Yeah.
So before we wrap up, I've got a couple closing slides here. Perfect. There we go. So James just mentioned you can move your applications to the cloud very easily. Along those lines, we've recently announced support for clustering on Jboss EAP on app service. So this means if you have applications which use features like stateful session beans, transaction coordination, high availability, or any other EE features which require worker-to-worker communication, you can now run those applications on app service without refactoring or removing those features. It's very easy to set up. You just have to join your Azure web app to a virtual network, like we're showing here in the diagram. And then when you scale out horizontally to more instances, those workers will communicate over the virtual network. Now, we went over a lot of content today, so go ahead and check out these resources. The first QR code on top is a link to the Jboss on Azure module, which we're seeing here on the screen. And then down below is a demo that you can go through for deploying a clustered application onto Azure App Service. So in that demo, it gives you an ARM template and instructions to deploy all of the infrastructure. So all you need is an Azure subscription and Java installed locally. Thank you so much for watching today. If you want to reach out or have questions on anything we talked about in the session today, you can reach us at that email address. And thanks again. Have a nice day.
Thank you.
All right. Thank you so much, folks, for awesome demo. James, you surprised me. I was in shock.
I thought you were
Watching
surprised
that.
at my Oompa Loompa face. I don't know. I have no idea why I'm so red. Oddity.
No, I thought it was amazing because I've never seen that kind of demo, that kind of tool before. I heard about the toolkit for assessment and migration, but I never saw that integration level, like even like within Visual Studio Code, for example, the things that you showed. So that was pretty cool. Thanks for the demo.
Awesome.
I would like to invite our next speaker, Eric Kosler.
Hello, how are you?
I'm doing great, Eric. Welcome to the show.
Hey, everybody.
So, Eric, what did you think about this toolkit for Java EE migration?
I always like seeing these things. I know a lot of people have their Java installations that have typically been done on premises in the large server environments. You got to move them up to the cloud. And one of the things I saw in particular that I really liked on that is the role of finding older deprecated non-standard APIs and replacing them with the current Jakarta EE ones. Really helpful for people who have to migrate from a typical vendor application to the fully supported version.
Yeah, that is interesting. And what are some of the things that you're going to talk about that kind of relates to this topic?
So I always talk about the role of security, of what's happened in the Java platform since Java 8. How do I follow along with the standards to understand how Java applications are being attacked and how I can properly defend? Because sometimes you need to do that by changing a couple APIs.
So I think so, James. The toolkit actually it has a bunch of rules. So,
Right.
for example, Eric could probably write some rules in the context of security, like check this API is not being used anymore, things like
Yep,
that. Is that right?
absolutely. CVEs can be encoded in there. Any customer specific security issues or patterns, all of that can be encoded in there.
Okay. Okay. Awesome. So I'll let Jason and James go. Thank you so much for being here. And all right, Eric, you can start now. Thank you.
Sounds great. So with the slides that are up, what I want to talk about is security since Java 8 and just what's been going on in the overall Java ecosystem. So to introduce myself, my name is Eric Koslow. I began a long time ago in terms of software engineering. After I performed in the circus for a while, I went into software engineering, writing Java applications. And then starting at about 2009, I switched to do software security consulting of figuring out ways to compromise different applications, how to help people build newer applications. And since then, I've become very Java focused in the realm of how do we assess the security of Java applications, both from the JVM as well as applications. And I was also one of the former product managers of the Java platform for Oracle. And now I work at a company called Azul that produces one of the JVMs called Azul, Zulu, and Zing. Outside of that, in the overall community, I'm a member of the InfoQ editorial team on the Java queue. And I also have a class on hands-on cryptography with Java to help people secure Java applications. And last year, a number of us through a community called Fujay started doing just a jug tour, going around sharing our expertise with members of the community. And I did a number of presentations at different jugs, Silicon Valley jug, Central Iowa jug, Knoxville jug. I'm probably missing some others. And I just gave a presentation about how Java applications are attacked. And one of the interesting things that pertains to security is that there's always some kind of exploit going on. So for a while last year, I was talking about an exploit that went on in Atlassian Confluence that was so major that the US Cyber Command warned about it. Then back in December, there was Log4Shell going on that took over a significant number of Java applications. And just in last April, we had Springboard as well as a CVE called Psychic Signatures in Java. And the way that I want to break this talk down is to break it down into three key parts to focus on first, how Java applications are attacked. What are the risks that are going on and what are the ways that people are attacking different applications to break into them and pose a risk to your applications and the data that you have? The second is what's been going on in Java recently. How has the platform evolved since about the Java 8 timeframe, and what are the things that are coming soon so that we could realize the way that the ecosystem is evolving to mitigate a lot of these threats. And third is to leave with a series of defensive steps that people can do. These are the takeaways that you can do in your applications, in your runtimes, and just ways that you can go to keep your applications more secure to have a proactive defense. Now, one of the first things that I want to do is to go and just give a quick opinion, because everybody said, I always get the question of, oh, are you going to say something? Am I going to hear some bad stuff? I find that generally speaking, the Java teams and the Java community are doing a pretty good job of maintaining the security of the overall platform, which involves the JRE itself, as well as a number of the libraries and the places where people get those libraries. So whereas a little over a decade ago, there was a reasonable amount of risk with the realm of like applets and the sunsetting of those from browsers, now a lot of that has been mitigated. There's a series of significant controls in place, both technical controls as well as community controls. And the risk to Java applications has actually more to do with the way that they're put together and the types of data that they have. So the risk has shifted from being a technological risk of how do I defend my Java assets to now focused on the realm of what is the business goal that I'm actually trying to accomplish by the act of writing this code? What are the libraries that I'm taking? And how do I piece these applications together? Because that's what it is that we're actually processing. And that's the reason why we take these applications and deploy or migrate them to the cloud. So to look at a series of the CVEs and the vulnerabilities that we talked about a little bit ago, when I first started giving these presentations, Atlassian Confluence was being attacked, where attackers would just go and they would load up a Confluence instance and they would send a customized parameter to that Confluence instance. And what Confluence would do in that case is it would take that data that came from the user and it would pass it almost directly to a special library called OGNL, which stands for Object Graph Navigation Language. And the way that these attacks really looked is you look at the query string, the basic thing that everybody can manipulate. And the way that they were attacking it in this case was to just send data in a Unicode format. So that AAA \U0027, what the attackers were doing in this case was to just go in there and provide an OGNL expression that went after java.lang.runtime and told it to just execute a function. And what would happen is Confluence would look at that and it would say, well, of course I'm going to run these URL parameters that you gave me. Why wouldn't that be code? And of course, Confluence would just be simply taken over as a result of that being a CVE. Like you can't just execute and download code from anyone on the internet, so you just take over a Confluence instance. So is OGNL safe? OGNL is a perfectly safe library to use, but don't take remote input and pass that input as a code, or it gives people literally the ability to execute code on your server. Another vulnerability that occurred back in December of last year, it was called Log4Shell. A number of people had to deal and scramble with that. It was a full remote unauthenticated compromise, allowing remote code to be executed in a JVM when that JVM logged a certain signature. And you can see that signature and the code on the right on top of that license plate. And what happens is an application goes and it downloads and processes a lot of data and it writes logs as it did that. Well, if the logger ever encountered a certain string or pieced that together in some way, what would happen is it would go out and it would try to fetch a bytecode at that JNDI location right there. And if it was able to download that, it would go and it would download the code, the jar file, the bytecode at that location, and the JVM would execute it in order to try and run its code properly. So what happens is if you had something that operated in like computer vision and you decided to say, what's the license plate of this car? The natural thing that you would do is to log what you saw as the license plate. So what your JVM would do in this case, if you're using the vulnerable version of Log4Shell, is it would log and it would say license plate found was JNDI LDAP. I'm going to go download the code from that location and I'm going to run it. Naturally, that led to a remote code execution vulnerability and hurt a significant number of servers. There's other attacks. We talked as we segued into here about application servers and WebLogic and things. Deserialization has been a common class of attack where applications receive serialized data. And as part of what the application says the data is, it tries to run some of the code that it gets as part of the serialized object. And that leads to a number of system takeovers. Spring4Shell, similarly, what happens is the applications are taking various levels of remote data, and they're just executing code on these. And another CVE that went on, this one was just patched in the April critical patch update of all the different JDKs. It was called a psychic signatures. Yep, there's the link right there. What this says is effectively, if you give a Java platform a certificate, a certain set of certificate that goes between like the number of 0 and 1 for elliptical curve DSA, then the platform just became a little too trusting of that certificate and would basically believe anything that that certificate said. So the way to patch this is to update your JDK. But what's different about this attack here in passive signatures versus the other ones that were remote code execution is that this one is a little more passive. And the risk here is that encryption algorithm is part of the default TLS 1.3 implementation where a lot of cryptographic operations take place. So the common thread in all of these CVEs is really a mixing of data and code where a lot, in the case especially of the remote code execution vulnerabilities, the application would take the data that came in, and whereas that was supposed to be data, the JVM would actually execute it. And in the case of the psychic signature one, as well as a number of the others, the problems occur actually in downstream dependencies or libraries that the application actually uses. So in the case of Log4j, in the case of Spring4Shell, in the case of Confluence, each of these vendors who produced the library of the application, they patched and they fixed these vulnerabilities. But if you don't take those patches and those security patches and apply them and install them in your environment to mitigate the vulnerability, then you're still vulnerable and at risk. So a key thing, if you want to focus on how to improve your security, is don't mix data and code to take information from a remote user. And when there is a CVE or a known vulnerability in one of your dependencies, go through and take the time to update that dependencies. We all make mistakes. I don't want to say that Log4j is a bad library. It's great. Spring, we just heard from Josh about how great Spring is and how helpful it is for people who want to do cloud migrations. They're excellent libraries and frameworks, but please take the latest and most secure versions. But why do these things matter to developers in this area? Well, when it comes to security vulnerabilities, we have a couple years ago, Equifax lost a ton of data, especially in the United States. Your data was probably in it. The problem came from an unpatched version of Struts. There was a CVE, a known vulnerability in that version of Apache Struts. And as a result of that, they lost a significant amount of data and they were fined about $575 million. Who did that fine? It was the Federal Trade Commission. This is an organization that deals with security in the consumer markets and has actually been active in the past in the Java communities. They're the ones who settled with Equifax in that 2017 breach and issued the fine. And during the Log4j problem back in December, the Federal Trade Commission actually came out and they made a statement. And normally when you present, you're not supposed to read the things that are directly on the slides, but I'm going to read this quote here because it's particularly important to Java developers. When the FTC came out with a statement here, they said, the Federal Trade Commission intends to use its full legal authority to pursue companies that fail to take reasonable steps to protect consumer data from exposures as a result of Log4j or similar known vulnerabilities in the future. Now, it's relatively rare for those of us in the software development community when a governmental organization steps forward and basically says, hey, remember us? We're the guys who issue the fines if you fail to patch. We know about this vulnerability. So if you have vulnerable dependencies in your application, especially Log4j, which they list by name here, it's probably going to be time to upgrade those libraries. And over the course of doing about 10 years of application security, I've heard a lot of people say like, well, I can't get to that now. I get it, but these organizations are there. So like, of course, it's going to come from you. I have a bit of a sarcastic thing over on the right of, you're totally busy here. Don't worry about it. If you leave these vulnerable dependencies out here, you know full well what you're getting into and what your problems are going to be. But what's happened in the realm of Java security? What are the things that I can take advantage of in my platform to benefit from enhancements that have been made? And what should I know about what's gone on between Java 8 and Java 17? As Josh said before, it's twice the number, so it's twice as good. The major events that I see in the Java community that have gone on are a couple of them. There's modularity, there's a predictable release cadence. A lot of talk went on in terms of security manager deprecation that just occurred in Java 17, and then a couple other defenses in the ecosystem. So modularity is something that was introduced back in Java 9. And what I like particularly about modularity is it focuses on a decreased attack surface and really the boxing in of possible threats. Because if we look at the number of modules that go into the Java platform back when modularity was introduced, we see things like java.sql.rowset, java.instrument, java.desktop, java.management. And the nice thing that these do in a security landscape is they take a number of the threats that can occur against an application or the way that people can break in, and they put them into nice little boxes, because when they're in boxes, you can start to deal with them. So the java.xml module, for example, there's a number of attacks that go on against XML. One of which is XML external entity injection, where you can request files off of other people's system by referencing it as a file to include in the XML document. There's also XML bombs, where you can just cause things to explode by referencing objects themselves and make them take up a huge amount of memory. And by that simply being present in java.xml as a module, I can start to deal with that as a box. Similarly, Java.compiler, now that that's in a box, I can start to deal with the concept of JSP injection attacks as a box of something to deal with. Same thing with Java.SQL. If I want to worry about SQL injection, I should only worry about that if I actually use the Java.SQL module. And I'll talk about how to deal with that and what to do with those boxes in a little bit. But the next thing that I want to focus on is the role of a predictable, plannable release schedule. A new Java distribution comes out, a new JDK comes out about every 3 months, and a new major version comes out about every 6 months. And within these cycles, between all the vendors, between Azure, between Azure Oracle, between Microsoft, between Eclipse, there's periodic instances of long-term support releases. Now, the long-term support releases that we have in the community that you can use are Java 8, Java 11, Java 17, and probably in the future, Java 21 is going to become one of them. And as Azure looks at a number of the Java distributions in the market, you see that there's Java 8, Java 11, Java 13, Java 15, Java 17. And the thing here is not to look at this and try to memorize a large cycle, but just to recognize that every once in a while, there's a new Java version that comes out. And if I want to use like a Java 12, I can certainly do that, but I should plan on upgrading relatively quickly to Java 13 when that one comes out. Then I can go to Java 14 and spend a little bit more time at Java 15. So the major aspect that you want to pay attention to here is the fact that there is an update, which is how do I upgrade to the latest, most secure version inside of a single JRE, and an upgrade, which is how do I go between JDK 11 to, let's say, JDK 17. So by focusing on my ability to stay on a green distribution where my Java platform is fully supported, I now know that I'm going to get security patches for that JRE when they come out. Now, another thing that I want to cover in the realm of Java security is a deprecation of the security manager. This occurred back in Java 17, last year. And in Java 17, one of the things that they did is they proposed to deprecate the security manager, and they went through to deprecate it and marked it with a deprecated annotation. Now, what that means is it doesn't mean that the security manager is removed. It's still there. If you are using it, you're still welcome to do that. But if you didn't use it, don't start using the security manager. And as part of InfoQ, I covered a couple different articles on this. And the reason that it's deprecated is that the usage of the security manager and its use relative to different attacks and different threats wasn't really there. There were very few people who actually used the security manager. A couple people did. A couple different organizations did. Yes, there were some projects that use it, but the number of different groups and teams that used the security manager was not particularly large. And just joking around with a number of people, I've made the analogy that security manager is to Java what Radio Shack is to the mall, because a number of us, especially in technical professions, we all agree that Radio Shack should be a pretty cool store. You want a pack of resistors, you go to Radio Shack. You want to fix up the radio or the walkie-talkie that you found in the attic 10 years ago, maybe they sell that. But the simple fact is nobody really shops there. And when we come time to say, where do I want to go to buy something? None of us actually went to Radio Shack, even though we all thought it was a cool store for somebody else. Now, the security manager architecture was also, this is a thing that was created back in the old Netscape Navigator days, and it was primarily aimed to defend against Java applets, which is the role of portable code. How can I download code from someone else's system and run it on my computer without having to worry about my computer being compromised? It wasn't designed to defend the backend application. It was designed to defend a local computer from being attacked in the days before JavaScript was really able to interact and do quite a few things. So this is why the security manager dealt with browsers and applets that did a lot of work with NP API, the Netscape plugin API. And what I found particularly interesting is in spite of about a 10-year career in the application security realm, I met more people in about the 6-week period of writing 2 articles about the security manager than I did in 10 years of professionally going around and talking to software professionals. Lastly, security needs context. If you want to create a security manager policy file, do you know what policies you need or what files you need to run inside of a Tomcat or a Jboss? I certainly don't. Do you know, in the case of the Atlassian Confluence vulnerability, what OGNL statements you are accepting to run? I have no idea what those are. If you need to deserialize data, do you know what those classes are? I sure don't. So most of us had no idea what to provide the security manager and able to be actually able to use a policy file. But one of the major improvements that's gone on in the Java platform is the presence of security events inside of JDK Flight Recorder, where the Flight Recorder, which is a diagnostic tool to analyze what a JVM is doing, it actually tracks and records various levels of security information. So with the realm of deserialization attacks, one of the features that was introduced to Flight Recorder last year was the ability to record which classes are being deserialized. And by recording the classes that are being deserialized, you're able to take advantage of other defenses in the platform, such as the JEP 290 deserialization filters. So whereas before that feature was introduced in Flight Recorder, if you said, well, which classes should I place in this serialization allow list, most of us would have absolutely no idea what we should put in there, so we couldn't have provided a policy file. But now that I have the ability to extract the policy, the listing of application classes that I'm deserializing through Flight Recorder, I now can go and tell my application, here are the classes that I know I need to deserialize, so please only allow those classes to be deserialized, and I have the capability to apply an active defense. Now I want to go in and talk about the realm of defensive steps that you can actually do. So as someone who's building a Java application or running a Java application, these are the things that you can readily do in your environment to take advantage of different security practices. The summary of the steps here is, number one, maintain that patch cadence with the JDK in your library. The fact that the Java distributions come out on a predictable schedule means that I can plan that in to know to upgrade every once in a while. Two, I'm going to shrink the attack surface. I'm going to take advantage of modularity to decrease my overall attack surface and become less vulnerable to threats. And third is to apply some other JDK features. Now, when the Java platform comes out about every 3 to 6 months, what I know is that in about 3 months from now, 3 months from April, there's going to be a new version of Java. So I can go through and I can plan an update. If I want to use Java 17, I know that there will be 17.0 a number in about 3 months from now. Now, if you can't go and you can't patch that every 3 months, maybe that's a little too much. I understand. Nobody's here to come and tell you, hey, you have to update everything, and within 3 months, you have to do it on the day. It's okay if you need to plan and schedule and defend in different ways, but just don't sit on a JRE and say, like, Java 6 is fine for me. I'm going to use this thing for the next 12 years. Don't do that. Just get in the cadence of every once in a while, about every 3 to 6 months, do what you can to patch your JDK and get it from an actually reputable Java vendor, because there is something called Mystery Meat OpenJDK out there where different people build it and report a version, even though it doesn't have the right security patches. Kind of weird. Same thing, monitor your libraries. So any dependencies that you have, periodically update those libraries, periodically update those dependencies. If you use log4j, every once in a while, you want to rev that version so that you don't become vulnerable to like the next log4j that comes out. And if you don't do that, that's the thing that Equifax didn't do. And it's one of the reasons that they got that $575 million fine. And also their CIO went to jail. He didn't go to jail because he didn't patch the vulnerabilities. He went to jail because he did insider trading on the knowledge of vulnerabilities. But still, anytime prison is involved, you generally don't want to be there. Now, another thing that you can do in the Java platform is there's a tool called JLink within it that you can use to reduce the overall attack surface of your application. So what JLink does is it creates a standalone JRE for that individual application. And what it does is it actually removes a number of the modules. So for example, if you're not using java.xml and you remove the java.xml module, then you don't need to worry about anything in terms of XML bombs or XML external entity injection. If you remove java.compiler, there's no way that you can be hit by a JSP injection. So technically, you shouldn't be worried about these things anyways, because you're not using XML. Why would XML load? Well, maybe it's fine to not worry about that, but the simple fact is you can't attack what isn't there. So by taking JLink to remove modules and just not having those modules at all, you're definitely not vulnerable because people can't attack what isn't there. Another thing that I would do is to leverage JDK Flight Recorder. So as I'm monitoring the performance of my application, I want to be able to record and stream different security sensitive events as well. What classes am I deserializing? What files am I accessing? What database queries am I running? By having a lot of this information come to me, I can gather a significant amount of this information and I can have a lot of it come my way and just get a feel for what's the security of my application, and I can get the benefit of some aspects of performance. Now, in the realm of security and just overall community, one of the questions I'm asked on a regular basis is, how do I get access to some more information and where can I go to just learn generally good things? Outside of an individual tutorial, what I want to cover is just a series of people in the community who are quite good and quite knowledgeable about the realm of Java application security. I'm up in the top left. That's me. I'm Coslow on Twitter. I don't post a ton. I probably should. I focus on Azul, Zulu, and Zing, which are the JVMs that are provided by Azul. And my specialties is, or my special expertise is Java security. Also reporter on InfoQ. Down in the bottom left, some other people who are quite knowledgeable to pay attention to are Jeff Williams and Arshan Dabergiagi. They were the founders of Contrast Security. They do a lot to handle a number of different languages, and they've published a lot of helpful information, like Jeff wrote an Enterprise Rootkits paper a while ago. A lot of this information is just helpful, and it's nice to have some generally good takes. Otherwise, in the top right, one of the people who was involved with the deprecation of the security manager, his name was Ron Pressler. He's a member of the Oracle Java team. He's the primary guy on Oracle Project Loom in Java. I forget which Java version that's coming out at, but I found him to be a pretty knowledgeable person about security in general, and he tends to have a lot of really good opinions. So when Ron says something or just has an observation on things, I find him to be a generally good guy to pay attention to. Lastly, if you're looking for a group that you can join or an area where you can just find what are a lot of things that are happening in the overall Java community, I'm a member of a group called FooJ. It stands for Friends of OpenJDK. The Twitter handle is FooJ.io. So if you're looking for how do I just hang out with a number of people in Java, how do I just talk and get a feel for what's going on, feel free to jump over to FooJ, make some friends, join. If you want to write an article, that sounds great. Just come join and hang out over on the FooJ community. And with that, I want to say thank you very much to everybody for listening. And the primary takeaways that you can do on your own individual Java applications is, one, update your Java about every 3 to 6 months as best you are able. Update your dependencies also. 2, if you have an application that you're distributing and deploying to an area, do what you can to shrink that JRE down with JLink, because you'll reduce the attack surface. And 3, use JDK Flight Recorder as you're able to extract a significant number of security events. And if you do those 3 things, you'll hit a relatively decent baseline in terms of security and be able to improve your applications. All right, thank you.
Thank you so much, Eric. It's good. It's always good to see a security talk, because as we as developers don't put too much work on that. We don't pay attention. It's something that sometimes it's an afterthought. Sometimes like build the application, deploy, and then we fix security. But I think the industry as a whole is doing this like shift left security approach, where security is a first thought, not an afterthought. And having these resources, I think it's quite interesting how you're seeing developers reacting to these needs. And the toolings, the tools available are good, but is there anything else that could be done in general?
Yeah, the tools that are available to your average developer are pretty decent. Like they're pretty good. They'll get you a lot of the information that you need. In terms of reception for using those tools, people care about security. The developers are happy to do it. They just need a clear articulation as to what that is. because what I found from a lot of people, and having been in the security groups, both on the giving and receiving end of advice, is that often the advice is like vague or impractical. Like one of the pieces of advice that I always hear is validate your inputs. Well, validate them for what? Because the way that I want to validate an input against SQL injection is very different than the way that I want to validate it for path manipulation. So one of the things that I like that's going on in the community right now, and with kind of less of the shift left, is defending based on context, which is what are you actually trying to accomplish through this code? And so I just do security by asking two simple questions, which come from actually there was an old Microsoft guy who did a threat modeling card game, which is what are you trying to defend, and what are you defending it from? And if you just focus on those questions, it's actually not all that hard.
Awesome. Thank you. Let me invite here on stage Antonio Goncalves and Eric Diendré. Is that right, Diendré? Is that the right way to say it?
It's D'Andrea, so I'm Italian, so pretend the D, it's a D and apostrophe. But
all right,
when I say it, that's how everybody spells it, with D apostrophe.
Awesome. All right. Well, thanks for being with us and teaching us a little bit of Italian. It's always good. My Portuguese is a little bit rough these days, and I'm sure Antonio's French is. Excuse my French. How are you?
Desculpa o meu português. Well, good. Thanks for having us.
Awesome. So good to see your face and seeing you smiling. And I'm so excited you're speaking at a Microsoft conference. And like everybody know you as this Java author, Java EE author for many years, and now you're working here.
Quarkus author too.
Exactly. So, well, thanks for being here with us. What are your thoughts on the security thing that Eric was talking about? Like, how critical is this, and how Quarkus helps?
How Quarkus helps, I would say, if you take what has been said, the release pace of Quarkus is quite amazing. And every month there's a new release. We go from 2.3 to 2.4 to 2.5 with updating all the dependencies and also keeping pace with the JDK version. I think the industry has shifted in the last 5 years where companies will upgrade the JDK once every 10 years, and everybody was freaking out and wow, shall we do it? And now I think it's becoming a routine. Everybody is updating the JDKs, the libraries, and the runtime like Quarkus.
I think containerization has helped too, because now you don't have to go install the JDK on all these different servers and God knows where in what corners of your data centers. Containers, the apps come with whatever the version should be, which is good and bad because it can make the ops teams pull their hair out. But
yeah, I think for decades we were like, yes, update this library. Just go to the latest library, but the JDK, don't touch the JDK. Right? So people were used to update open source technologies all the time, but not the runtime, which is also open source. So it's weird, right? So I think it goes back to your point, Eric. Like people want, especially ops team, they want to make sure that the runtime is the same across everywhere, so their existing tools can work and monitor and all of that. And it also makes their job easier. But that's because the runtime was installed on the server on the VM, and they had to manage. But as you said, now that this shifted to the container, now it's kind of becoming a developer role to maintain that, not only the libraries, but the runtime that ships along with the application. And I know Quarkus has this deployment model very similar to Spring Boot applications where everything goes together in a container. So awesome. I think that is where we are at. I think we're going to show awesome stuff for Quarkus. So Eric, thank you so much for the security talk. It's amazing. So I'll let you go now. We'll have a wonderful day. And Antonio and Eric, please take the show from now on.
All right. Great. Thanks very much. So I'm Eric D'Andrea. I'm here with Antonio, and I'm not even going to attempt to say it. So when we get to your slide, I'll just let you pronounce it because I'm not gonna go down that road. So if you go to the next slide, please.
Oh,
you're driving.
Yep.
Yeah, you're the driver. You're in the driver's seat right now. So for those who don't know who I am, I'm Eric D'Andrea. I work for Red Hat. I've been doing software development for 20 some odd years, mostly in financial services, insurance, and whatnot. I've been in the open source world for a long time. I'm a current contributor to Quarkus. I've contributed to Spring a lot in Spring Security back in the day. I build training programs. I've written a book, and that's about me. You can find my Twitter handles and LinkedIn and all that kind of stuff over there.
Well, my name is Antonio Goncalves, and as Bruno said, I'm from Microsoft. I'm a principal software engineer at Microsoft, even if I have this Quarkus jacket. But why do I have this jacket? Because I've been, developing for many, many years, and most of it in Java EE. I follow the entire J2EE and Java EE and Jakarta EE thing. And in terms of runtime, same thing, WebLogic. I used to be a BEA system developer. And through all this history, here I am contributing on Quarkus. And like Eric, I wrote a few books, a couple on Quarkus actually. And I also talk at conferences, mostly about Java, Quarkus, and recently cloud stuff around Azure.
All right, so we got 25 minutes. I think we've actually got a little bit less than 25 minutes now. So get ready to get your face wet, because we're going to throw a ton of information at you in a short period of time here. So really, we're going to start off by doing a demo. We're going to talk about the Quarkus superheroes, what they're all about, and how they work. And Antonio's going to talk about some Azure goodies behind the scenes of what we're doing here. I think it's some new stuff that a lot of people aren't quite using yet.
Exactly. So
off we go.
Off we go.
To save the day. So here's the system. So the application that we're going to describe is a system for being able to pick superheroes and supervillains, and you can pit them against one another. And there's some super secret algorithm behind determining the winner. The joke is, if you can go find the code and tell me what the algorithm is, we'll give you some kudos on Twitter. But that being said, it shows you the who wins, who loses in real time. And then on the left side there, you've got this record keeping application, which is watching what's going on and keeping track of kind of keeping them as teams of heroes and villains, which team has won the most battles, and then computing the top 10 winners and who's won the most there. So it's pretty simple. It's easy to demo. It's easy to show, but as you'll see, there's a whole bunch of stuff behind the scenes that we're going to talk about here.
Well, wait, because there's more villains winning. I'm trying to make the superheroes win. Anyway, so let's go under the cape. Let's talk about the architecture of this system. As you can see, if you are a web developer, you could have easily done that with HTML, CSS, and jQuery. But because we are backend developers, we made it slightly more complex. But there's also a reason. Each time you talk about a technology such as Quarkus, you always throw a bunch of Hello World samples, Hello World on how to access a database, Hello World on how to have a REST API. This sample is way more complex. It's a bunch of microservices. I will explain it. And it's complex in terms of code, in terms of architecture, but it's also a nice way to learn, because there's documentation on this application. It's fully automated CI/CD, so the tests run. It's you can deploy it with Docker Compose or Minikube. So it's a nice application when you want to learn more about Quarkus and bring a higher level of complexity. So no, it's not jQuery. First of all, the UI. So the UI is a separate application, a SPA, single page application, written in Angular. It could have been another framework. What's important is the UI it talks to a microservice developed in Quarkus, of course, called the Fight microservice. So the Fight is the entry point of the UI. When we click on New Fighters, the UI invokes the Fight microservice to get a new villain and a new hero. How does this work? Well, the Fight microservice actually talks to other microservices. The hero microservice is another one written in Quarkus 2 with a Postgre database. So on its own database, there's all the lists of the superheroes with the image, with the bio, and the magic number here will tell, with the power of the superhero. Same for the supervillain. So there's another microservice with its own Postgre DB, and that will give you return a random villain. So each time you click on New Fighters, it invokes the Fight microservice, which invokes the hero and the villain microservice. Then, when we want to fight, we click on the Fight button. And again, we invoke the Fight microservice. Like Eric said, it has a funny algorithm, take the superpower, does a bit of magic, and that's the microservice that will compute and will let you know who is the winner and who is the loser. And we call that a fight. And a fight between a villain and a hero will be stored on a Cosmo DB. And if you look at the list underneath, that's actually a query on the Cosmo DB database. And once we have this fight, we also send it to a Kafka stream. So there is a message defining who is the winner and who is the loser, if it's a villain or if it's a hero. And on the other side of this Kafka stream, we have another microservice with its own UI, the statistic microservice that refreshes itself thanks to WebSockets. Each time it listens to the Kafka channel, it computes the top winner and returns and displays, the statistics. So all that is written in Quarkus. So maybe Eric, you could tell us a few words on Quarkus.
Yeah, so I know we don't have a whole lot of time, and so if we talk about hey, we're riding up in an elevator here, what can I tell you about it, because we don't have a lot of time. 2 minutes doesn't quite do it justice. So if we move to the next slide, Quarkus is essentially a stack to build distributed systems. And if that word distributed systems wasn't there, you'd probably think I was going to say microservices, right? But Quarkus focuses more on just microservice. It contains all the pieces and building blocks you need to build pretty much any type of application you can envision. So, a full stack framework using all or most of the technologies that you are probably already using, things like JPA, Hibernate, JTA, JAX-RS, Liquid-Based, GraphQL, Vertex, gRPC, Kafka, all that kind of stuff is already there and already part of the platform. It's also based on a container first philosophy, meaning that it tailors the application for GraalVM and the hotspot JVM. So you're boasting really fast boot times, really small RSS memory usage, and pretty near instant scale up and scale down with really easy and no hassle native image generation. That can really shrink your application to things to be much smaller and much faster on the JVM. And GraalVM really loves the code that you write with Quarkus, because Quarkus tailors and makes GraalVM understand what it is without the user really having to think about it. So, furthermore, combining imperative and reactive, Quarkus doesn't really care which paradigm you write in. You mix and match within the same class, even if you want to, and it'll just kind of figure out what it needs to do from a threading model. Kubernetes native, so the combination of Quarkus with Kubernetes, being able to deploy and run and all the tooling around doing that, it makes Quarkus really, really good. But something people don't touch on a whole lot is what we call developer joy. So things like, hey, I wrote my code and I want to see it refresh up to date immediately without me having to bounce my JVM, or be able to spin up other downstream services. In our examples here, we're talking about using databases in Kafka and MongoDB and all that kind of stuff. I shouldn't have, as a developer, I shouldn't have to care about what those services are or where they are. If I'm doing local development on my machine here, they should just be provided for me, and Quarkus will do that for me. A fan like me, I'm very into test-driven development. So, being able to write my tests, write my code, and have the framework understand the relationships between my code and my tests. So.
Okay, so what about deploying this entire architecture? So we mentioned those microservices, and Eric talked about the containerization, and that's also the beauty of Quarkus. It's really, it's out of the box. You can easily create a Docker image when you create a Quarkus Bootstrap. So everything here has been containerized. So even the UI, the fight microservice, the villain, the hero, and the statistic. Then, so that's for our business code. Then to deploy all these containers in Azure, we will see what we will be using. But it's important to stress out that we've deployed our code in containers, but we've used all the managed Azure services like the Postgre or the Cosmos DB for MongoDB, or Azure Event Hub for Kafka. So the demo that you saw, it's our code deployed in containers, but using all the Azure services.
I mentioned too, we use the native image version. There's images for JVM and for native, and we are using the native ones.
Yeah, we will give you the URL of our repo, and you'll see that for each microservice, we've packaged it in using Java 11 and 17 and native or JVM. So in this demo, we deployed the native one. So Jason was mentioning app services, earlier. In Azure, we also have AKS, so it's a Kubernetes platform, but we've used Azure Container Apps, which is the new kid on the block, because, as we said, it's very easy to create a container out of a Quarkus application. But once you have all these containers, how do you deploy them? And some people will say, well, Minikube or Kubernetes or other frameworks like that. So it's quite complex when you are a developer. You don't want maybe you don't want to go to the Kubernetes world. So Azure Container Apps, it's actually a good one. It's a fully managed Kubernetes platform. So you deploy your containers on Azure Container Apps. Behind the scene, there is a Kubernetes doing all the magic for you, but you don't actually see it, and you can't even customize it. So you don't see the underlying VMs or orchestrators or all the infrastructure. Even the network is simplified, which is very nice. And then it can auto scale, and I'm going to show you, a demo. The orchestrator notices if you need more instances or not. So Azure Container Apps can scale up and down your containers just by looking at what's happening in the system. It's built on open source stack such as Kubernetes, as I mentioned, but also Kida, Kubernetes even driven auto scaling. So that's all the auto scaling magic, Dapper and Envoy. So that's Azure Container Apps. So how did we deploy the application? We actually used Azure CLI. So we have this command that goes az container app create. And then, so I'm giving the simplest example where we deploy the UI. And in Azure, you always start with a resource group. But then you give all your microservices the same container app environment. And that's very important because all the microservices will run in the same environment. They will share the same network, so you don't have to configure it. So that's nice. All our microservices were deployed in the same environment. You give it an image. Remember that the idea is to deploy a Docker image that is published out there. In our case, it's deployed under Quay. So it's not even Docker Hub or the Azure registry. It just, it could be even your own, of course. You give it a name, it's microservices. You said that this app should be used by the outside world. And what's important is we are deploying this Docker container, but in this case, we need to configure it. In our case, we need to give it the URL of the fight microservice. Remember that the fight is the entry point. So with --m-var, you can configure your container. And a more complex example is the fight. So we use Azure Container App, resource group, same environment, a different image, and so on. And then we configure Kafka. So in our case, it's the Azure Event Hub URL. We also configure, the MongoDB connection string. So in our case, it's Azure Cosmo DB. And because fight talks to hero and villain, we give it the URL. And I'm gonna come back to the demo because I was telling you that Azure Container Apps automatically scales up and down. So here, if I click New Fight and we wait for a couple of seconds, I should have a fallback. Yeah. What happens is I made a request. Azure Container Apps, in the meantime, while we were talking, scaled down to 0. So I didn't have my microservices. And now if I click again, they are back because Azure Container Apps has scaled to 1. End of my demo. I stop sharing my screen. Eric, all yours.
Yep. What's interesting with that is when we were rehearsing yesterday, we actually couldn't get it to fall back because the apps were, the native images were scaling up so fast. If someone wants to go and look through the code, it shows off all the fault tolerance that's built into Quarkus, and it has like a timeout that if it doesn't get a response within a certain period of time, it'll respond with some default data, and we actually couldn't get it to do that. So I was like just trying to decide whether it was a good thing or a bad thing if we couldn't make our app blow up. But I guess it's a good thing. So let's for just very fast, we're going to talk about let's make a very, very fast enhancement. So rather than just simply debugging it in an environment, what if we, now that our application is wired and it's live in a, I'm going to use air quotes here, a real environment, let's do some rapid development and prototyping. Definitely not something you're ever going to do in production, right? But if I want to be able to iterate, and I don't want to have to stand up all these different services on my machine, what if we could do some little proof of concept and then we commit our code and it goes through our CI/CD pipelines and all that good stuff that others have talked about? So what if we decided, hey, how does the fight algorithm really work? What if we did the battle 5 times each time you click the button? What would the result be the same all 5 times? So what I'm actually going to do is I'm going to come over to my code and I'm going to run Quarkus in what's called its remote dev mode. So it doesn't really matter whether the app's running in a container, on a VM. It doesn't matter as long as it's just some remote environment. My local ID, and it's not a plugin with the ID, it's part of Quarkus core itself. I can instruct it to the Maven or Gradle plugins to connect to that remote instance, and it's now synchronized through a WebSocket to whatever it is. So as I start making changes here, it'll synchronize the remote instance. And so what I'm going to do is I'm just going to make a change to the method that handles the fight. And instead of just doing it once, I'm going to do it 5 times. And this is a reactive application. So I need to do it in a reactive way. So I'm going to say create by repeating. And then the work is going to be the.
So here, Eric, you are updating code live in production.
I'm updating live in production, right?
How cool is that?
And I can't change the method signature because then I'd have to go change the UI to receive all the updates, right? So I'm only going to return the last one to the UI, but as soon as I save that and I come back over, and if I refresh my page here, it's synchronizing over. And we'll pray to the demo gods. Yep, so it just sent. So now I got my app up here, and if I click fight, you notice over here I've got 69 battles, and if I do new fighters, I click the button again, now I've got 72, so it's going up by 5 each time. And if I refresh this page, you can see, the last 2 times I did it, it actually did it 5 times. So I didn't build a container.
5 messages.
Yeah, it's sending 5 messages.
Okay.
It's storing 5 records in Mongo, sending 5 messages over. I didn't build a container image. I didn't push it to a registry. I didn't deploy it. It's direct live from my local machine up to the running instance.
Love it.
That's pretty cool. All right, so we're getting close to the end of time here, so we'll leave you with just a few additional resources for those who are looking for more information. As we talked about at the beginning, I've written a book, and it was actually Eric Costello, who was here before us, actually did a review on Fuji of this book, back, I think it was late last year, early this year. So it was nice to meet him, quasi in person or virtually. But I wrote a book. I've been active in the Spring community for a long time. I've been doing Spring for a really long time, for dating back to like 2010, 2011. So when I started learning Quarkus, I was like, when you learn something new, you're always comparing it to things you already know. And you're always saying, well, I did it this way with this thing that I know. How is it the same, or how is it different? And so that's why I actually took all of last year, or most of last year, and wrote this book that looks at different patterns and conventions from Spring, and how would you do it in Quarkus, and then what are the differences and what are the similarities. And I focus a lot on testing, because you find like a lot of like the quick start guides and how-tos and whatnot, they talk about how to do something, but they don't necessarily talk about how would you test that thing that you just built, which I'm a huge fan of test-driven development. So I always focus on how would I test the thing, because if I can't test it, I'm not going to build it, right? So that's a free book for anybody who wants to download that. And I think you've got a few as well.
Yeah, I've got a couple of books also free. They are on the Red Hat portal. One is Understanding Quarkus. So really it goes topic by topic, how to do injection, how do I access a database, how do I expose REST APIs. And then you have a practicing Quarkus book where you start from a blank page and you create an entire microservice architecture. So start with my Understanding Quarkus book, then practicing, then Eric, and then switch to Spring, and then come back to Quarkus, something like that.
All right, and just a few references for those, some of the links, the GitHub repo for the superheroes that has all the services that we talked about. There's a guide for if you want to actually deploy it on Azure Container Apps. There's a guide there, and I'm a huge fan of the easy button. I don't like to copy paste. I just want to type a command and have it done. So we built a simple script. It's got lots of command line options to customize how it works. I think there's a workshop as well, and I think that was actually where this superhero sample application came from originally. It was, came from something that you had built a while back.
Yeah, I created that 2.5 years ago. Quarkus was brand new, so I created this workshop and with other Red Hatters, and we played it at several conferences, and got his momentum, and then it was turned into a sample. So today you can still find the workshop, and you can do it by yourself, and you have the sample application. Though that's why we are showing you the 2 repos.
Yep. And then there's a blog that just kind of introduces, if you're more interested in how are the services built, what they do, what their conventions are, that goes into a lot more detail about the actual services. And that's about it. So, hey, it's been great working with you, Antonio, and thanks a lot for working on this.
Yeah, thanks, Eric, for the remote dev that I didn't know of.
All right. Thank you, folks. This was exciting. Thanks for the live demo. Always good to see live demos being presented live on the internet, and they work.
Yeah,
Plus,
you should have seen me 10 minutes into at the end of Eric's talk, because my Azure environment crashed and I had to redeploy everything like 10 minutes before I started.
Amazing. So we are on time for the next session, but I want to introduce the next speakers. So let's bring on stage lots of them. Yolande Poirier, Teresa. Excuse my French. Teresa Nguyen. And
good.
Good, okay. And Dalia Abo Shiasha. Did I say that right?
It was so good.
I told
just
you
like that talk, Antonio and Eric. It was fascinating.
Awesome. All right. Hi, Yolande. How are you? It's been a while.
Yeah.
Awesome.
I'm doing great.
Well, thanks for being here. So we had lots of sessions about technical stuff, but we know that to be a professional in this industry is not only about technical skills. It's not only about knowing how to hack into things and write code and whatever, but there are certain parts that are needed to shape someone's career. And that is where I think you three here to talk about. Is that right?
Exactly. Yep. We're here to talk about how you can have a more fulfilling career within Java. I know a lot of the talks out there are not as specific. We wanted to kind of frame it in the Java universe. And we thought this would be a nice way to close out the conference.
All right. Awesome. So Antonio and Eric, thank you so much. You guys have a wonderful
day. Thanks for having us.
Bye.
Nice.
Good luck.
Bye, guys.
All right, so the three of you, please, it's your show now. Thank you.
Awesome. And I am sharing my screen. Let's see if it comes on. Great. Hi, everyone. Thanks for sticking around. There's been a lot of awesome talks so far. And this talk, it's going to be me. I'm Dalia. I am a product manager on the Java at Microsoft team. And I'm joined by my two awesome co-speakers, Yolande and Teresa. Let them introduce themselves.
Right, so I'm Yolande Poirier, and I'm actually a manager at Neo4j. I'm managing a team that is of community managers. But so just for historical purposes, a couple of years ago, I was at Oracle, and I was a community manager for the Java community. And so I know pretty much some of the speakers here, but a lot of the work that I did then is also coach people to contribute content to all our web properties. So there was like blog articles, videos, and also we were running a community track at Java One, so helping people also to build their skills and become speakers for the first time. So all those best practices that I learned with the Java community, I'm trying to build a team that can do that at Neo4j. So that's
great. I'm Teresa Nguyen. I'm also a product manager with the Java Microsoft team. So I've done my stint in the kind of open source startup world, working on 2 application servers. If you remember back then, about 15 years ago, the Resin application server, and also recently the Tommy Tribe application server. Now I'm with the Java engineering team working on tooling. So I'm glad to be here to talk a little bit about, what it's like to have a career in Java, and also different points in your life. Basically, not everybody here has done 20 years of programming in Java, but how do you get started and things like that. So hopefully this session will help everyone out.
Yeah, I got really excited when I was invited to this session because I've been a Java developer for many years. I had a very fulfilling career. first as a developer, individual contributor, then a developer lead, and then a developer advocate, and now a product manager. And it was all within the Java ecosystem. So I thought it would be really cool if we could come in and talk about some of the roles that are available and some of the skills that you need in order to continue within your career journey to have a more fulfilling career. So one of the first questions I ran into was, I've been in my role for many years. What's next? I remember being a developer, I had delivered a bunch of code, fixed a bunch of bugs, and just it became a cycle. And I was wondering, what's next for me? What do I want to be doing? Like, I wasn't enjoying my role as much. And I wanted to see what else is out there, but I didn't know where to start. One of my favorite ways to start having that conversation is asking myself, what have I enjoyed doing so far within the career I've had? So, for example, when I was a developer lead, I had an opportunity to go out to conferences and speak to developers and bring back some of the product insight that I got from the developer and talk to the product teams. And I later discovered there's an actual role for that, which is developer advocacy. And I decided to pivot into that role. And it's been kind of one of those things that I've done on kind of semi-regular basis, where if I feel like my career has stalled, I reflect back, I figure out what have I really enjoyed about what I've done so far, and how can I do more of that? And I know that's just one example of how I've done it. So we wanted to dive a little bit more deeper into how to make that decision. And Teresa's going to first help us with that.
Great. Thanks, Dalia. So, getting to know yourself and your career ambition, I'm sure everybody have thought of this at one point in time in their life. So let's take a quick tour into the career clarity. And, thanks to COVID, the last 2 years, I'm sure a lot of you had a lot of time to reflect on life, family, priorities, and even careers. So I want to take this opportunity to share with you some of the things that I think are important. The goals and the aptitude, you're probably familiar with that, your goals in life. You're already a Java developer, so you probably during COVID thinking, what's next for me? Do I want to continue being a developer or not? Your aptitude, this kind of encompasses your natural skills, your talent, your education, everything that you want to put down your CV. So, but maybe instead of thinking of it as a KPI, think of it as a KPT. Like, what's your knowledge base? What are your personal traits? And what kind of transferable skills you have? These are important things to know. But let's step beyond that and look at some other things that are interesting. This can be your interests, your values, your personalities. These are things I don't think we spend a lot of time taking a look at or even talking about it. But these are the important elements that helps you in terms of prioritizing your decisions and choices. And your personality is important because, things like, as we discovered last a few years, work culture, maybe working from home is more productive for you instead of going to the office, or maybe you're an extrovert or an introvert. How does this help you accelerate your career? So let's now take a look at how do you expand your skills and interests to match your career. So knowing yourself is just kind of like the beginning. You already have your skills, there's constant learning, but let's go into what else can you do to align your priorities and get your career going? So that's why I mentioned earlier the interests and personalities and values are important, because in here you have everything that you need for your CV to get your next job. But in today's open source, or in today's technology, open source is being used everywhere. So why won't you just leverage the open source and build it into your career path? This is something that you can contribute to, grow your career, help build a healthy ecosystem, and take advance to the next level. And if you're not really good at self-assessment, then consider taking the Myers-Briggs exam. It's free, it's online, or you can do it as a professional development, and it'll help you assess your own attributes and career path. So now let's take a look at some career consideration based on the premise of you knowing yourself and what kind of career path you might want to consider. So in here, if you want to, if you're in engineering already and want to stay there, you don't have to continue being a developer. If you want to take a look outside to see if there's other suitable options, you can look into product management or being a TPM or even UX design. All this can leverage the skills you already have and then further skills that maybe you want to acquire. If you go into the cloud, going into information technology, learning about networking, platforms, architecture, storage, all that. It's more product based, but it really does help you advance your career as people are looking into, what kind of cloud options are there. And if you find yourself as being an extrovert and you want to maybe reach out the community, do less behind the keyboard pecking and more of talking, sharing your knowledge, doing demos, then an outreach role such as DevRel or product marketing is more suitable. So all these are not they're not an exhaustive list of career paths, but these are options you should maybe consider as you are learning about yourself. And of course, if you want maybe to be in a less technical role, but have the techno foundation to advance your career, business strategy is also a good option to look at. And this can be anything from legal to business development. And so this is, just keep in mind, these are options on how to take your career to the next level. So let's see what we can do here. So if you're a Java developer and you want to continue, and let's see how we can use open source technology to help you advance your career. So open source, it's like any other product. It's a software, it needs innovation, it needs maintenance, it needs contribution. So using open source, you can take it further and contribute and get more out of it. It's like an accomplishment, and where the field is leveled out. You don't have managers, you don't have higher ups telling you what to do. You're basically your own boss. You contribute whatever you want to contribute. And I listed here some ways of I listed here some projects. So the two main ones are Eclipse and Apache Foundation. Those you can start exploring what kind of projects are in there. Jakarta EE and MicroProfile, more of a standards body. So if you want to maybe work on standards instead of particular projects, you can start looking to that. And I've listed some other projects here like Kafka, Tommy, or JMeter, Spark. The important part here is if you're already working on a product at your company that utilizes open source, start looking at these projects. You might be able to get a start in open source that way. And as you're starting to look at open source, just remember the 4 pillars of open source is use, contribute, and use, contribute, and give back to the foundation. So let's look at the 10 ways you can contribute to open source. All right, I'm not going to go through all this. And thanks, Emma Irwin from the Microsoft Open Source Program Office. She supplied here a link here where you can go find out more, 10 different ways or 8 different ways. I added a few more to start contributing. So here, you don't have to always contribute code. You can contribute in different ways like marketing, governance, even diversity and inclusion. There's so many ways you can do this. But so what do you do now? I know some of you guys are already contributing, but there are those out there early in the career that haven't started contributing yet. First off, you should create a GitHub account. Once you do that, you can go in there, browse around some projects, start looking at, you can search under topics like Java or search under the libraries that you're already currently using. Start looking at also larger projects because there's going to be more people and more likely you'll get help in that way. So, and then once you go in there, you can start checking out, some of the contributing guidelines. It's important. If there isn't one, you can look at the README. It'll give you some guidelines, some insights in terms of how to commit your first PR. And before you start committing things, raise an issue or take a look at some of the discussion in the community. It will help you understand what's important and what's not important. Then move it to an issue before you start working on it, and then commit your first PR, because you don't want to commit something that people are not ready to maybe take action on. So, and remember, open source is not it's a marathon. So don't cram, don't think that you have to do open source every day, every week. You can do it, once in a while. And plus it's not a weekend or an evening job. You can bake this into your day job. So don't cram, just continue to contribute. And another way to also further your career with open source is look at the future employer. If they're using a certain type of open source technology in their project, maybe start contributing to that project. It'll give you some visibility, give you some experience. And when they're ready to maybe open up a role in their project, you can apply and get, up on the list of interviews. So in short, join a community, join a discussion, help evolve open source projects, and it will evolve your CV. So now that you know how to contribute to open source projects, consider more than code contribution. You can also create content for the ecosystem. So let's hear what Yalan have to say about content creation.
Okay, so how do you create good content? So I've seen a lot of people struggling with like how to get started. And so this is where my coaching, this is really based on my coaching experience. So what I found is that a lot of people don't spend enough time, first of all, researching topics, right? And you want to make it easy. So you have to look at what you're doing today. Like what kind of topic would be easy for you? Are you like working on a cutting edge or technologies, like or something that people really look for, like microservices, for example, or the latest Java release, right? But if you're not, then you can also look at open source projects, so what you're doing there, or what people are also really looking for. Like there is always a demand for new people coming to Docker and they don't know what to do, for example, or the complexity of Kubernetes. You can certainly find something there that and as you learn, you can also share that learning experience. So that would be more of a beginner kind of process. So you don't have to be an expert to contribute content. That is very important. Because what I've seen is like people think of like writing a book, for example. Well, you don't start there, right? You start with like a small blog or even code or something much smaller. So once you decide roughly like what kind of area you're comfortable or you're interested, so you have to look at what is out there. So who is actually talking about those topics? What kind of content they're producing? What works? What doesn't work? Right? I mean, everything is on social media, so there is more than you can learn so it's unlimited, the content, the research that you can do, but restricted to, like check the Java champions. You're in the Java ecosystem. So who is actually producing that content? Look also at what is trending. So you have macro trends like AI and ML, but you also have macro and micro. So this is the micro, it would be like Quarkers. So something a lot smaller, but that is just in the ecosystem. Understand why those trends are happening. What kind of problems are people looking to solve? And once you have that answered, you will see like a lot more opportunities, things that you never thought about. So once you've done that, make sure you pick a type of content you want to produce. Don't try to do everything at once. Pick one. Are you more comfortable doing videos? Are you more comfortable writing? Or do you say, well, no, I want to do neither, right? I rather code. Then in that case, go back to open source project, for example, or contributing to technologies that you care about, right? So again, start smart, start small and simple, right? So next, Daria. So, and the research is not done, right? Step 4 is test your ideas. So once you have kind of an idea of what you want to do, run it by people, run it by your team, run it by your JOG members, run it at conferences. Like maybe there are conferences, BOFs, for example, where you can have the discussions, but make sure you discuss it, because as you are discussing this idea that you want to develop, people are going to give you suggestions. They'll suggest other tools that you can use. They'll say, no, we tried this, but it didn't work. And, you will learn a lot. And all that learning, you can actually integrate it in your content that you're going to produce. And you can thank also people that contributed to that content and ask them to push to help you promote this wonderful content that you promoted as a result, right? You created as a result. So you see that now I'm in step 5, and you still haven't written pretty much anything. So those 4 steps are very important to design your content. Once you start creating that content, still make it very simple. Focus on a problem. Maybe you can do a series of blogs. But the first blog that you write, make it very simple. And the structure for most technical content is problem, solution, and result. Conclusion, right? But very focused. They all have the same format, right? If you want to do something, if you're doing like a career change, then maybe you have like a series of advice that you can share, or product comparison. So that depends also on the career change that you want to do, but be very focused. Lastly, step 6 is I get a lot of people who ask me, well, should I have my own blog or should I or not? And my recommendation is certainly you can have your own blog because it's good for your brand, but you should also consider all the other aggregate websites where you can share your content. So for example, all the companies I've been at, we had either a Medium or a Dev.to website channel, I should say, and we accepted a community contribution. I've never seen people really contacting me and say, hey, I would love to contribute content to your site here. And that would make my job easy, actually. So look for those opportunities because they do exist. It's just that people don't know and don't realize that. And also, we are always looking for new beginners content. And because when you build a community, you're not just looking for people who are like, say, Java's champions, for example. You also want content that that beginners can start with. And the best people to create this beginner content are actually beginners. So this is important to have like different people building content. And also, all those companies out there, they also want more Java champions, right? I call them champions. Every company has their own advocacy program today. So this is a starting point. So you start contributing content and then you become a champion eventually, right? Another resource I want to mention is Fuji, because Fuji is also an independent entity who is looking for content. So you should actually follow them on Twitter and also contact them and see and suggest a topic. They'll let you know. The only thing they can do is say no, right? Okay, next slide, because I think I'm running late. Okay, so now you have to also promote yourself, right? Okay, so promotion. I took this example because this example, Vlad does such a good job of just showing who he is. And there's so much information in his profile. So first of all, he has a big picture there, right? So we see him talk at a conference. So that means he's a speaker, right? The picture that he uses the same pictures everywhere. So if you want to find him on a different platform, you just look for his picture, you'll find him. He uses name. Yes, no funny name. It's I've seen like very people who are top contributors not using their real name, making something funny, and I've seen them their network grow a lot slower as a result. And then his description, he gives you, so he's a Java champion, so he gives you like his credential, right? He's a Java champion, he's an author, and then he tells you exactly what he's going to talk about. And so you know exactly why you are following this person. And so for your profile, you have to tell people what you're going to talk about, because that's the reason why they should follow you. Sounds obvious, but it's actually super important. And for people like me, who is looking for people to recruit, to engage and grow my community, this is a wonderful profile, because I know exactly who is, and I can actually reach out to you and invite you to my community and to contribute. Okay, then the lot of what I hear also is like people will tell you it's too complicated. Social media takes too much time. I don't know what to do, right? I don't have like 10 more hours to spend on social media and chit-chatting with people. I totally agree, and you shouldn't have to do that either. So what he does, so first of all, his style is totally straightforward. Right? It's one sentence. It tells you exactly what you're going to get, right? You get tips. Well, here it is. It's in the title, right? You see in the URL that actually is directing you also to his own blog, right? That's also important to have just like a URL that shows you where you are going to land. He does a lot. He answers a lot of questions on Stack Overflow. And so you can see it. He actually shares it on social media. So this is also important. Don't reinvent and start looking for content on social media and invent a different stream. No, talk about what you are doing, right? Integrate that into your workflow and show people what you do on a day-to-day basis. So integrate this strategy. The other thing, the third post that he has in here is actually his GitHub project, and because he contributes to Hibernate types. I think it's his own project actually. But same thing, it just tells you what it is. It doesn't get into any emotional consideration or whatever else. And the screenshot that he has are also just directly related to the content that he's talking about. So make it simple. If you remember nothing, just like find a way. There is always a way to make it simple and simpler, so.
Awesome. Thanks, Yolan. So I know we have just a couple minutes left, so I'm just going to wrap it up here with some next steps. So after the talk, what should you do? I highly recommend the first step is to just sit down, grab a pen and paper or your laptop or whatever, and think back to your career. Think about what have you enjoyed doing so far? What are some of your interests? What are some of the values? All the things that Teresa talked about, and write some of those down. For example, when I was a developer, I really liked the design process of software. So I was thinking, oh, maybe an architect would be interesting. Or like, do you like to contribute to open source? Would you like to work on a different project? What area would you like to work in? JPA or something else? Just sit down, figure out what would be really interesting to work on next. Second step is to look at the slide that we had where Teresa had all those roles and map some of those interests to those roles and figure out, would that make sense or would that bring me joy? Would I like to be a software architect? Would I like to be a developer advocate? Would I like to contribute to this open source project? Third step is going to take the longest, which is to build those skills. Because when you're coming from a developer role to another developer role, it's kind of easier to demonstrate that you've done that role. But if you're pivoting from one role to a different role, like product management or architect or whatever, you need some way to demonstrate that you've done that work or you can do that work. And some of the ways that you can do that is open source contributions. So you can follow Teresa's recipe of contributing to your first bug, contributing content, all that. Or you can follow Yolan's recipe of contributing content around the areas of expertise that you'd like to be in. That's one way that I've demonstrated that I know Docker, is creating a course around Docker, intro to Docker. And that attracted people to say that, oh, Dalia has expertise in Docker. Fourth step, I know it's a little bit uncomfortable for people to promote themselves, but if no one knows that you've contributed so much great content out there, you've contributed this code or this content or this blog or this talk, they won't be able to find you. So highly recommend promoting your work. And this is where I'm going to leave you. Thank you so much for attending this talk. And I hope you had a great time at JDConf.
All right, thank you, Dalia. Thank you, Teresa, Yolan. I want to ask you a question. I keep talking about YAML on Twitter. Is that the right thing to do to promote my content? Am I doing it right?
I think Yolan has opinions about that.
Don't.
Don't. Okay. All right. Thanks for the advice. Not following. Well, all right. Thank you so much for this. This is great content, and I think lots of developers really want to grow on that path. There are the kind of developers that just want to get their job done, 9 to 5, go to the office, code and stuff, and it's okay as well. Some developers really want to grow to, or not necessarily not even grow, but really expand career options. And I think what you presented here allows them to open different doors and pave different ways to grow their careers. And I think that is what matters. Like for those that want to do those things, how do they do that? And you just show that to the audience. So thank you so much. And we'll continue to connect over social media. Thanks. Have a wonderful day.